Hello there, and welcome back to this quiet corner where science drifts slow enough to dream by. Tonight, we're not chasing galaxies or peering into distant nebulae. We're turning our gaze towards something closer, something that might be hurtling through our own solar system right now. A traveler from another star. And the question that keeps astronomers half awake at night is simple. What if something shocking hits 3I Atlas and no one expects it? Imagine that. A cosmic visitor streaking in from interstellar space, crossing the quiet outskirts of our solar system like a letter from nowhere. We've seen one before, Oumuamua, that strange tumbling shard that didn't act like a comet or an asteroid. And 2I Borisov, a true comet from beyond. Then came 3I Atlas, another wanderer, carrying frozen secrets from light years away. Now picture it colliding, not gently passing by, but meeting something else head-on, out there in the cold dark, where time moves at the speed of dust. Imagine standing on a frozen ridge of some forgotten moon, watching as two ancient travelers cross paths. The silence is total, no sound, only light, expanding outward in slow motion. A streak, then a blossom of vapor and rock, silent but immense. The flash glows against the black, like a slow exhale of creation. And for a moment, space remembers what chaos feels like. You can almost smell the metallic frost, the ozone, the ancient dust vaporizing into light. Somewhere, faintly, the echo reaches the sensors of a telescope 500,000 miles from Earth, and a few nights later, someone at their desk blinks at the data and whispers, "That's not supposed to happen." But before we get there, before we talk about what it means for something to hit an interstellar object and why it matters, let's pause. Maybe you're listening late at night, the room dim, the air still, a quiet hum in the background. Maybe you're winding down from the day, letting curiosity take the place of caffeine. If so, thank you for drifting in with us. Leave a small comment, if you like. Tell me what time it is where you are, and whether your sky is clear tonight. Because while the cosmos feels infinite, we're here, sharing this same thin moment together. Now, as you settle back, dim the lights, and maybe turn on a fan, let's play with some impossible questions, the kind that sound absurd at first, but keep you up thinking anyway. What happens when two travelers from different solar systems collide in ours? Would we even notice? Could a telescope like James Webb see the chemical fireworks of such an impact? And what if that explosion wasn't just ice and rock, but something stranger? Could it send debris inward toward us with messages, minerals, or microbes older than our sun? Or what if it missed? Would it alter the path of 3I Atlas, sending it spinning toward the inner planets on a new, unpredictable course? And so, before we watch what unfolds, we need to slow down, way down to the speed of orbits and shadows. Because the story of 3I Atlas doesn't begin with an explosion. It begins quietly, far beyond Neptune, where sunlight is only a rumor, and time, like gravity, bends softly around whatever passes through. That's where we'll start, in the silence before the shock. Let's begin where silence reigns on the edge of everything. You're standing at the outer rim of our solar system, where sunlight fades into rumor, and warmth is only a memory. Out here, time feels like it's holding its breath, and somewhere beyond Neptune's long, lonely arc, something moves small, dim, and older than memory. It's not supposed to be here. But then again, nothing really is. Long before anyone noticed, 3I Atlas had already crossed the invisible boundary that marks the edge of our solar system. It drifted in silently, a shard of another star's debris field, cold and ancient, reflecting only a fraction of sunlight. It wasn't born here. It didn't belong here. But space doesn't check passports. It simply lets things pass through. You could almost imagine hearing it a hum too slow to be sound, a vibration in the dark fabric of distance. It moves with the calm confidence of something that has seen 1,000 suns rise and die. Its surface is mottled, glinting faintly as it spins, like a mirror remembering faces it once reflected. You picture it coasting, unbothered, the way a ship drifts into a quiet harbor long after the sailors are gone. The first of the 10 rhymes drifts into your mind. Simple and slow, cold stone, far flown, alone, and unknown. It's not a poem, exactly just the universe whispering in couplets. Imagine standing there beside it, or as close as anyone could, your boots magnetized to a speck of rock floating through nothing. The stars don't twinkle out here. They glare like patient eyes. The sun, from this distance, is just a small coin of light, a flicker barely strong enough to cast a shadow. And around you, the void hums softly, as if exhaling secrets from 1 billion years ago. Dark sails, pale trails, the cosmos exhales. You don't feel fear, just a strange, calm curiosity. Because even in the quiet, something in you knows this visitor is older than imagination. Maybe it was born near a red dwarf that cooled and died. Maybe it was part of a shattered world, flung outward by gravity's mischief. Or maybe it has been traveling since before the sun was born, a frozen time capsule carrying messages in the language of atoms. Ice gleams, slow streams, drifting through dreams. From a distance, 3I Atlas looks ordinary, like countless other comets catalogued by weary astronomers. But ordinary is just what extraordinary looks like from far away. Up close, you'd see cliffs of iron dust, seams of frozen methane, and hollows carved by eons of cosmic wind. The light glints off it faintly, silver turning to blue, blue fading to black, a spectrum of stillness. Stars spin, shadows thin, silence begins. You picture what it might have seen on its journey. Nebulae, like stained glass cathedrals, the birth of stars in clouds of fire, the quiet death of worlds that never had names. It's easy to forget that space isn't empty. It's filled with history written in dust, and 3I Atlas is just one of its many drifting paragraphs. Gold dust, frost crust, wander we must. There's a kind of poetry in its loneliness. You imagine it gliding for millennia without witness, unbothered by meaning or mission. It's not searching for anything. It's simply obeying inertia, the oldest law in the universe. Yet now, by cosmic accident, it's passing through our backyard, and we tiny, blinking creatures on a small blue dot are the first to notice it in perhaps 100 million years. Thin light, endless night, still in flight. Telescopes strain to track it. A handful of data points appear on a monitor in Hawaii, a flicker of light too faint to impress anyone at first. But then the numbers start to misbehave. The orbit doesn't curve as it should. The path suggests it isn't bound by the Sunday. It's passing through a traveler, not a captive. Somewhere, an astronomer leans back in their chair and mutters the same words we've said to every mystery since time began. What is that? Long glide, nothing to hide. Cosmic tide. You can almost see it now, sunlight brushing across its frozen face, a soft shimmer of vapor rising like breath in winter. Every glint is a syllable, every rotation a sentence. It doesn't announce itself. It simply exists, humming through the void like an uninvited thought that won't go away. Cold sea, drift free. What will it be? And you, the quiet observer, can't help but feel it's not entirely alone. Because every now and then, The light from its surface flickers just slightly off rhythm, as though something inside is adjusting, remembering, waiting. Still flight, silver night. Almost right. The data streams home. Observatories confirm. Another interstellar object. Another messenger from nowhere. Scientists give it a name. 3I Atlas. A string of numbers, letters, and catalogue entries. But you and I both know that names don't contain stories. They just label them. The real story begins not with discovery, but with what happens when something from out there crosses into here. Stone sings, distance clings, gravity strings, and so the quiet arrival continues. The visitor keeps gliding inward, slow and patient, carrying secrets no one asked for, but everyone will soon want to know. You close your eyes, listening to that endless hum. It's not the sound of space, it's the sound of time, passing gently as 3I Atlas drifts toward the light. Let's drift closer now, past the quiet arrival and into the first whispers of confusion. You're standing at the edge of discovery, peering through a telescope's narrow circle of light, and there it is, a blur, a smudge, a mistake in the math. The astronomers lean in. Someone adjusts the focus, and the image sharpens. It's faint, yes, but real, a slender streak sliding across the dark, like a chalk line drawn by a ghost. To most telescopes, 3I Atlas looked like a comet, a faint smear with a long ghostly tail. But its orbit was wrong, too fast, too steep, too hyperbolic. It wasn't looping around the sun, it was passing through. That alone made it a messenger from somewhere else, a story from a different solar system, just brushing against ours before moving on forever. You might imagine it like this. You're on a quiet road at night, headlights off, and suddenly, something whips by so fast, your coat flutters. You don't see it clearly, only feel its presence and wonder where it came from. That's how astronomers felt. The data didn't fit. The trajectory ignored everything they knew about gravity's polite etiquette. It wasn't orbiting the sun. It was saying a quick hello and heading for the exit. For weeks, telescopes tracked it obsessively. They plotted positions, corrected for error, recalibrated equipment, and still, the object refused to behave. Even the most skeptical scientists began to admit the impossible. This wasn't one of ours. It came from out there, from the endless space between stars, the dark pasture where gravity forgets your name. Imagine watching that long, pale tail stretch behind it, thousands of kilometers long, glowing faintly against the void. Each particle in that trail is a frozen breadcrumb from another world, a record of chemistry older than our solar system. If you could scoop it into your hand, though your hand would have to survive temperatures near absolute zero, it would glitter like powdered glass and smell faintly of burnt metal and sweet alien frost. You could almost taste it in the air of imagination, like licking the surface of a forgotten coin left on a frozen windowsill of another planet. Not that you should. Your tongue would become the newest moon of 3I Atlas. As it approached the sun, its light brightened, the tail widened, curling ever so slightly, a long arc of vaporized gas and dust, painting an invisible calligraphy across the night. But beneath that beauty, something felt off. A normal comet sheds material predictably, releasing gas as sunlight warms its surface. But 3I Atlas seemed to breathe irregularly, like it was hesitating, exhaling once, then waiting centuries before the next breath. Astronomers described it in technical terms: non-gravitational acceleration, outgassing asymmetry. But what it meant was simpler. The object was moving in ways that suggested it had preferences. Not like a machine, not like a mind, but like something responding to old instructions from a long-forgotten origin. You watch through the telescope, your breath fogging the eyepiece, and you can't help but wonder how many others like it have come and gone, unseen. How many quiet visitors drift through our solar system each year, undetected, carrying fragments of other suns in their bones. You feel small, but not in a sad way, more like a cell in a living organism, finally realizing the vastness of the body it belongs to. If you could follow 3I Atlas, you'd trace its path backward across tens of thousands of light years, past the Oort clouds of dead stars, through the ruins of forgotten systems. Maybe it passed by civilizations long gone, their worlds now frozen embers. Maybe once, long ago, it brushed close to another inhabited world, and someone else, under a foreign sky, made the same discovery we just did. Maybe they called it something beautiful, something we'll never hear pronounced. There's a comfort in that thought that we're not the first to look up and wonder what this faint blur could mean, that somewhere, across the slow heartbeat of the galaxy, other beings have squinted at their own version of 3I Atlas, puzzled, inspired, and quietly afraid. And if that sounds far-fetched, remember the odds aren't against it. The universe is vast, and curiosity might be its most common language. As scientists continued to observe it, they noticed another detail: the sunlight reflecting off its surface wasn't constant. It flickered in a slow, rhythmic pattern. Not random, but not entirely predictable either. Like a coin tumbling in slow motion through the dark, its glint pulsing in a sequence that made you think if light could hum, this is what it would sound like. Some said it was a coincidence. Others quietly, late at night, when coffee had replaced sleep, called it a signal. Not a message, perhaps, but a signature, proof that somewhere in the chemistry of its icy crust, the universe had left a kind of fingerprint. And that's when the conversation shifted from curiosity to possibility, from what is it to what if. You close your eyes for a moment and imagine it up close, a frozen cathedral drifting through eternity, etched by cosmic wind, carrying the scent of forgotten stars. It glides past Saturn's orbit, indifferent to the human eyes watching from billions of miles away. It will never know we saw it. It doesn't need to. Its story isn't about being seen. It's about passing through, untouched, unchanged, and eternal. And as it moves closer to the heart of the solar system, you can feel that faint tension in the air, that sense that something extraordinary is about to happen. Because this visitor isn't just another comet. It's the beginning of a mystery that no one is ready for. Let's step quietly into the control rooms, where the hum of machines and the clink of coffee cups replace the silence of space. It's here, under fluorescent lights and too little sleep, that the universe begins to confess. Not in words, but in numbers. Cold, impartial, and sometimes terrifyingly honest. When astronomers ran the numbers, their equations didn't smile politely. They whispered something unsettling. 3I Atlas was interstellar, unbound by the sun's gravity. Every trajectory they plotted ended the same way. It wasn't staying. It had entered our system at impossible speed and would leave again just as quickly. Like a tourist who doesn't stop for photos. You can imagine the scene. A group of scientists squinting at a monitor, their expressions shifting from interest to disbelief. One adjusts their glasses, another rubs their temples. The numbers aren't broken, they're just rude. They refuse to make sense. Someone refreshes the data, hoping it'll behave on the second try. It doesn't. It just keeps insisting that 3I Atlas came from nowhere we know and is heading back to nowhere else. You feel it too. That small electric jolt of realization, the kind you get when your GPS says, turn left, but there is no left. The models are perfect until they meet something that refuses to fit. The math doesn't lie, but it does smirk sometimes. To understand it, you picture gravity like a polite host. Everything that visits gets drawn in, slows down, loops around for a while, maybe stays for dinner. But 3I Atlas? It showed up, looked around, and said, "I'm good, thanks." It moved too fast for the sun to grab hold of, slicing through the solar system on a hyperbolic path, bound to nothing but its own momentum. The data came in waves: right ascension, declination, velocity vectors, each one confirming the same impossible story. At perihelion, the point of closest approach, it was moving at more than 90,000 miles per hour, fast enough to make any planet feel like a stationary rock. The orbit diagrams looked like vandalism, a single slash through neat ellipses. It wasn't orbiting, it was cutting through. Some astronomers laughed, that awkward laugh you make when the laws of physics suddenly feel like a prank. Others grew quiet, because this wasn't just fast, it was foreign. The numbers placed its origin far beyond the Oort cloud, maybe even from another arm of the Milky Way. And that meant something unsettling. Space is more connected than we think. You glance at the simulation on screen, tiny blue dots for planets, yellow for the sun, and a red line for 3I Atlas, an angry scar across the solar system's perfect geometry. It enters from the north, dives past Mars's orbit, then swings back out toward the void. No looping return, no second act, just a single, elegant escape. Someone in the lab jokes, "It's on a galactic road trip." Another murmurs, "Yeah, and we're the gas station it didn't stop at." Everyone chuckles, but not too hard, because beneath the humor sits an uncomfortable truth. We don't own this corner of space. We just rent it. The equations, when plotted backward, hinted at a path that may have taken 3I Atlas through interstellar space for millions of years. Imagine it drifting between suns, grazing the edges of dead systems, its surface scarred by cosmic rays, its core colder than thought itself. No engines, no guidance, no destination, just physics, patience, and the faint glow of starlight brushing its side once every century or so. That's the part that gets you, the patience of it. You think about your own life, the deadlines, the endless notifications, and realize this object has been traveling since before mammals were a good idea. Its momentum is older than our species' ability to count. It doesn't rush, but it never stops. And then someone notices something peculiar in the data. The curve of deceleration near the sun isn't perfectly smooth. There's a small anomaly, a tiny deviation that shouldn't be there. It's subtle, like a skipped beat in a song only mathematicians can hear. The cause? Unknown. Theories pile up. Uneven outgassing, measurement error, gravitational influence from an uncharted mass. But deep down, everyone's thinking the same forbidden thought: what if it wasn't natural? The math answers softly, "I don't care what you believe. I'm right." You lean back, letting that settle. Numbers don't need drama. They have certainty, but humans do. And so, amid the graphs and the coffee stains, speculation blossoms like mold. Could something so precise be coincidence? Could something so old be random? Could the universe really fling such a thing into our path, just to say nothing at all? By dawn, the whiteboards are covered with equations. The room smells like dry erase markers and stale triumph. Someone finally sighs and writes 3 words in the corner of the board. It's just passing. And that, somehow, feels worse than anything else. Because if 3I Atlas is truly interstellar, then it's proof we're not alone. Not necessarily in life, but in motion. We're part of a galactic current, sharing space with wanderers that never stop long enough to say hello. And as it races away, carrying our reflected sunlight with it, you can't help but feel a strange gratitude. The math may not lie, but it also doesn't comfort. It just tells you what the universe already knows, that everything moves on. Let's drift closer again, not to the object itself, but to the halo it leaves behind, the ghostly mist that refuses to behave. You're floating now, somewhere past Jupiter's orbit, watching a faint smear of light unspool behind 3I Atlas. It's not much to look at. At first, a ribbon of dust, soft and luminous, trailing in slow motion, harmless, predictable. Except it isn't. Comets shed dust when they're warmed by sunlight, but 3I Atlas began glowing too early, long before the heat should have reached it. The gas around it was wrong, strange compounds, unknown ratios. It was as if it remembered a different kind of star, one that burned hotter, or older, or maybe not at all. Astronomers began to whisper, maybe it wasn't ice at all. You can picture the confusion in labs around the world. Screens flickering, scientists leaning forward, squinting at emission spectra that refused to make sense. The colors were off deep blues and unexpected greens. Comets usually glow in cyan, the result of carbon gases fluorescing under sunlight. But this one, it shimmered like oxidized metal, shifting shades as though it couldn't decide which universe it belonged to. Somewhere in a basement observatory, a grad student whispered, "It's alive," half as a joke, half as an apology. The room laughed softly, but no one dismissed the idea completely. The glow wasn't following any known pattern of sublimation. The ratios of carbon monoxide, hydrogen cyanide, and formaldehyde were all wrong. Not impossible, just misplaced, as though they'd formed under a light we've never seen. You imagine standing close enough to see the surface, patches of crystalline frost, tiny jets of vapor hissing into the void. Each jet glows for a moment, like a dying candle in slow motion, then fades. It's beautiful, but unsettling, the kind of beauty that hums slightly out of tune. The dust it throws off doesn't scatter evenly either. It coils, forming filaments that twist and braid together, like cosmic handwriting that refuses to be read. To you, it looks like art, a painting on a black canvas the size of eternity. To an astronomer, it looks like bad data. Either way, it's mesmerizing. Some compared it to Oumuamua, the first interstellar visitor, but 3I Atlas was different. Oumuamua reflected sunlight sharply, like polished stone. 3I Atlas diffused it, creating an eerie halo that pulsed faintly every few hours, almost rhythmic, almost alive. The dust density didn't match the light curve, meaning something was making it glow without actually shedding much mass. A contradiction, plain and glittering, drifting quietly past the orbit of Mars. Imagine breathing near it, if breath were even possible out there. The dust would cling to you like powdered glass, sharp and cold. Each particle older than humanity, each one containing molecules forged in the belly of a long-dead sunday. You'd glow too, faintly, just by being near it. Not from radiation, but reflection, like standing too close to a thought that isn't yours. Back on Earth, the headlines began. Comet that defies physics. Alien chemistry discovered. Space rock breaks the rules. You could almost hear the sigh from every astrophysicist. They hate when the media calls things alien. Yet privately, they couldn't help but agree the composition really was alien. In the literal sense, it was matter that hadn't been born in our solar nursery. It belonged to another lineage of starlight entirely. One researcher proposed that 3I Atlas came from a binary system, two suns, locked in a gravitational dance, their light alternating in rhythm? If so, then maybe the strange glow wasn't a mystery at all. Maybe the comet had simply learned to expect two sources of heat, two colors of warmth, and now, bathed in our single, weaker sun, it was reacting like an exile longing for home. That theory spread quietly through the community, poetic, yes, but oddly comforting. It gave the data something to hold on to, yet the more they observed, the less comfort remained. The dust trail wasn't dispersing as it should. Normally, radiation pressure from sunlight pushes debris outward, spreading it thin until it disappears. But this trail stayed tight, cohesive, as though something was holding it together. Gravity couldn't explain it, nor could static charge. The particles seemed to be communicating, adjusting, aligning, microscopic choreography in the vacuum of space. If you could magnify the scene, zoom in on a single mote of dust, you might see it shimmer faintly, pulsing with energy absorbed and re-emitted in intervals. Each speck flickering like a pixel, part of a larger, unseen pattern. Maybe it's random, maybe it's not. By now, observatories everywhere were locked on the target. The James Webb Space Telescope, with its golden mirrors, angled like the eyes of a god, caught glimpses of the spectrum. The results came back with one anomaly circled in red, a spike at a wavelength that didn't correspond to any known molecule. Something out of place, something new. In that moment, you could almost hear the collective breath of humanity being held, because that's the kind of data that either wins Nobel Prizes or redefines what natural means. And so the whispers grew. Maybe it wasn't ice. Maybe it wasn't dust. Maybe 3I Atlas was shedding something else. Something built, not born. You can feel the unease in that thought, like static before a storm. Because if the dust isn't just dust, then what exactly is drifting toward our star, glowing before it should, remembering a light that no longer exists? Let's move now into the part of the story where quiet things start to collide, where the universe, in all its empty vastness, decides to play darts with dust and destiny. You're floating far beyond Jupiter's orbit, in that cold gulf where sunlight takes hours to arrive, and warmth is just a rumor. Everything is still, serene, indifferent, until, of course, it isn't. Far beyond Jupiter's orbit, something moved small, dark, silent. An asteroid, a fragment. No one noticed until it was too late. Its orbit crossed paths with 3I Atlas at just the wrong angle, just the wrong second. There was no sound, no flash visible from Earth, just a change, subtle, mathematical, in the path of a traveler that had never planned to stay. Out here, collisions are not dramatic Hollywood explosions. They are whispers of momentum, nudges of probability. When two objects meet at tens of kilometers per second, there's no fireball, no roaring soundscape, just kinetic poetry. A spray of fragments so fine they disappear in your palm, moving at a speed that could erase continents. It's violence without theater, and somehow that makes it worse. You can almost picture it, 3I Atlas, gliding like a quiet guest, unaware that a speck of forgotten rock, a wanderer from our own solar system, has entered its lane. The two are billions of years old, yet they meet like strangers on a dark staircase. For a moment, gravity's choreography falters. Then, impact. No one on Earth sees it happen. The moment passes in total silence, but the aftermath ripples out in data. Telescopes tuned to the object's faint light start noticing anomalies. The brightness dips, then spikes. The orbit shifts by fractions of a degree, a hair's width on paper, but enough to rewrite everything. Astronomers run the math again, expecting a glitch. But numbers don't panic. They just report. The trajectory has changed. Something happened out there. Something invisible, but undeniable. And in science, that's all it takes, a number that refuses to behave to turn curiosity into obsession. You imagine standing there, watching the collision unfold in real time. There's no explosion, just a shimmer, like frost cracking under invisible hands. Dust sprays outward, curling in slow arcs. Tiny chunks drift apart, glowing faintly as they tumble. You could almost call it beautiful, if not for the creeping realization that the universe has just improvised. Scientists begin pulling data from every observatory. They cross-check light curves, compare orbital velocities, build simulations. On one monitor, a faint cloud appears around 3I Atlas, expanding slowly, irregularly. One researcher mutters, "That wasn't there yesterday." Another leans in and whispers, "Neither was the deviation." The collision was a ghost event, a thing that left fingerprints but no witnesses. Yet its consequences begin to multiply. The dust trail, once tidy and slender, starts to twist. The light it reflects pulses in uneven rhythms, as if trying to communicate something no one yet understands. Somewhere, a physicist tries to model the impact using old equations. Newton, Euler, Kepler. The math collapses into gibberish. Too many variables, too little predictability. Space, it seems, doesn't like being told what to do. Then comes the first real clue: heat. Instruments detect a faint infrared spike from the coordinates of 3I Atlas. Too faint for combustion, too persistent for coincidence. Whatever hit it didn't just bounce off, it changed it. The outer crust warmed by several degrees Kelvin, then stayed that way, as though something inside had begun to stir. It's absurd. Of course, rocks don't stir. They absorb energy. They radiate it back. But not this one. This one seems to be holding on. And if space has taught us anything, it's that when something refuses to cool down, it's time to start asking uncomfortable questions. What if the fragment wasn't random? What if, hidden among the trillions of uncharted asteroids, something else had been moving in parallel all along? What if this wasn't the first time 3I Atlas had been touched? That thought spreads through the scientific community, like a whisper through a monastery, soft, but impossible to ignore. A few researchers begin quietly using the word event instead of collision. An event implies meaning, coordination, intention, even. Most dismiss that as nonsense, but a small, exhausted few, the ones who've spent their lives chasing impossible anomalies, pause before they disagree. Back on Earth, the public barely notices. The news cycle hums, along with politics and sports, while a speck of cosmic debris dances silently through the outer dark. But for the people watching, for the ones awake at 3 a.m., under the pale light of computer monitors, it's as though the universe just winked. The next morning, a new image arrives from a deep space observatory. The faint glow around 3I Atlas has grown. It's not just reflecting sunlight anymore. It's emitting light faint, but measurable. Not constant, but pulsing. Regular, almost rhythmic. A headline is born. Something hit the interstellar visitor and it's not cooling down. But you lying in bed, listening to this story unfold like a dream, know the truth already. Out there, where no one can hear, two ancient travelers brushed shoulders and the math shivered. What followed wasn't chaos, but choreography, a new step in a dance we weren't supposed to see. And as 3I Atlas drifts onward, carrying fragments of another world now fused into its own, you can't help but feel that something in the void has changed direction, not by much, just enough to remind us that space, like fate, has a sense of timing. Let's step into the silence that follows an accident the universe didn't mean to cause. Imagine floating somewhere between the orbits of Jupiter and Saturn, surrounded by blackness so deep it feels physical. Out here, there's no horizon, just distance. The stars don't sparkle, they stare. And then, suddenly, for the briefest flicker, one of them blinks. For a brief moment, space lit up where no light should be. A flare, faint and short-lived, like a cosmic exhale. Telescopes registered a spike in ultraviolet, then silence again. Scientists stared at the data. It wasn't a solar flare, not a gamma burst, not anything expected. Just a blink, and then 3i Atlas wasn't behaving like 3i Atlas anymore. It's strange how something so brief can echo so long. The flash lasted less than a second, but in astronomy, that's a lifetime of questions. The data replayed again and again, one tiny spike, perfectly clean, perfectly wrong. No instrument error, no atmospheric distortion, just light appearing from nowhere, then leaving behind confusion. If you could have seen it from out there, it would have looked almost gentle, a sigh of radiance blooming and fading before you could blink. But the scale is deceptive. That tiny shimmer released more energy than an entire volcano. Only, instead of ash and smoke, it left behind a silence that hummed. You imagine being a dust particle nearby, drifting lazily through space for 1 billion years, when suddenly you're illuminated, your shadow born and gone before you even know you have one. For that instant, everything around 3i Atlas glowed dust, fragments, frozen gases, all shimmering with borrowed light. And then the dark folded back in, like nothing ever happened. Back on Earth, observatories scrambled. Transient ultraviolet anomaly, one report said. No known correlation. Another called it, simply, the flash. Someone joked that the universe had sneezed, but no one was laughing, because what came next didn't match any known cometary behavior. The flare changed 3i Atlas. Its rotation shifted slightly, its tail brightened, and its spectral signature, the chemical fingerprint of its composition, began to warp. Molecules that had never been there before appeared in the readings. Ionized compounds, metallic traces, and something that absorbed more than it reflected, as though the object had swallowed light and was deciding whether to give it back. At first, scientists tried to rationalize it. Maybe the impact from the earlier collision had exposed a volatile layer beneath the surface. Maybe the sunlight, reaching deeper pockets of frozen gas, had ignited a small outburst. That explanation worked until the frequency changed again. The flash repeated, not as bright, not as long, but undeniably rhythmic. Every 4 hours, a faint pulse, too regular to be coincidence, too strange to be comforting. You can picture the room where they're studying it. Walls lined with monitors, glowing blue in the dark. A pot of burnt coffee sits forgotten on a desk. Someone whispers, "It's pulsing again." Someone else checks their watch, as though that'll make it stop. And out there, hundreds of millions of kilometers away, 3i Atlas spins quietly, a flickering ember against the black. Each pulse releases a subtle jet of gas, not random, but directional, as if it's adjusting itself. Telescopes record everything: brightness, position, heat. But what no one can record is the feeling, that gut-level awareness that something out there just noticed itself. In time, the flash gains personality. Observers nickname it the heartbeat. Some call it poetic, others unnerving. But either way, it sticks. Every time the ultraviolet sensors twitch, people look up instinctively. even though they know the light won't reach them for hours. It's become a kind of ritual. Humans waiting for a heartbeat from a stone. Meanwhile, in the spectral data, something new emerges. Between the pulses, faint emission lines appear at regular intervals, right where no lines should exist. Not chemical, not thermal, structured, like coded breathing. A young researcher at a Chilean observatory runs the analysis late one night. The patterns resemble binary 0 seconds and 1 second of light and shadow. She doesn't tell anyone at first. She stares at the sequence on her screen for hours, then mutters, "That's not possible." But she saves the file anyway, under a name that says everything and nothing. Echo 1. Dart. For weeks, the pattern persists. The media picks it up, alien Morse code, while professionals roll their eyes and quietly recheck their instruments. Yet deep down, even the skeptics can't shake the feeling that this isn't just random, because randomness doesn't repeat on schedule. Still, no one can explain it. The pulse continues steady, precise, maddeningly indifferent, and each time it flashes, 3i Atlas alters course ever so slightly, like a ship testing its rudder. It's not enough to panic anyone, yet just enough to rewrite the math again. By the end of the month, the ultraviolet sensors record one last burst, brighter than the first. For a fraction of a second, the energy spikes tenfold. Then, nothing. The signal cuts off. The light curve flattens. Silence returns. But it's not the same silence as before. It's thicker somehow, charged, as though space itself is holding its breath. And you, listening now, drifting at the edge of sleep, can almost feel it. That quiet anticipation that something just happened far away, something small but irreversible. The kind of event that starts as a glitch in a telescope log and ends as a question humanity will never stop asking. What flashed out there, in that dark ocean where light rarely swims? And why, afterward, did 3i Atlas suddenly seem awake? Let's return to the darkness, where motion is the only sound, and balance is just borrowed grace. You're hovering beside 3i Atlas now, or rather, beside what it's becoming. It no longer glides through space like a steady traveler. It wobbles, it jerks, it spins, as if something deep inside has forgotten the rules of physics. The cosmos doesn't like chaos, but sometimes it tolerates a little drama. After the impact, its spin changed. Slowly at first, then chaotically. A wobble became a roll became a tumble. Like a coin spinning on a table, it began to lose balance. Its tail twisted, its light signature flickered in irregular rhythms. To anyone watching closely, it looked less like a comet and more like an object in distress. You imagine it a glittering shard against a sea of endless black, rotating through patterns that no longer make sense. Its tail no longer trails behind. Sometimes it wraps around, spiraling like a ribbon caught in a wind that shouldn't exist. Dust and gas spill unevenly from its surface, creating a twisted, luminous fog that drifts in slow arcs. If you could stand near it, ignoring for a moment that near means dead instantly, you'd see cracks spidering across its crust, glowing faintly with trapped heat. You'd hear nothing, because there's no sound in space, but somehow you'd feel it, the vibration of something massive trying to remember what stability feels like. Astronomers watching from Earth began noticing it first in the light curve, the plot that shows how an object brightens and dims over time. Normal comets pulse in predictable rhythms as they spin. 3i Atlas, on the other hand, started blinking like a broken beacon. Its brightness rose and fell erratically, sometimes by entire magnitudes. It wasn't just tumbling, it was flailing. At first, scientists assumed it was fragmenting. impacts can shatter comets, turning them into clouds of glitter that fade quietly into solar wind. But this one refused to disintegrate. Instead, it held itself together, as though bound by something stronger than ice. One astrophysicist joked, "It's like it's refusing to die." No one laughed. In one observatory log, a researcher noted, "Light pattern now irregular. Object displays secondary oscillation. Possible torque anomaly. In plain language, it's dancing, and we don't know why." Imagine watching it through a telescope, the faint shimmer of its body spinning, then slowing, then spinning again faster, as if something inside were shifting its mass deliberately, like watching a sleeping whale roll in the deep, responding to invisible tides. The tail, once straight, now whips and curls. Plumes of dust burst from its surface in uneven spurts, trailing in curls that twist like smoke from a candle in zero gravity. It looks almost deliberate, like a painter, flicking color into darkness. For the scientists analyzing the data, the chaos was intoxicating. The equations stopped behaving politely. Every simulation diverged after a few hours, the math unraveling faster than coffee could fix. A spin this unstable should have torn the comet apart. But 3I Atlas persisted, rotating faster than expected, losing no measurable mass. It was as if something inside was compensating a gyroscope correcting a fall. At this point, even the skeptics began to murmur. Could it be hollow? What if it's denser than we think? Could the internal structure be mechanical? Theories flooded in, none satisfying. A hollow comet would have shattered. A metallic one shouldn't glow. Yet 3I Atlas did both, spinning, sparking, surviving. The longer it tumbled, the more unpredictable its course became. It wasn't just rotating, it was precessing, twisting on multiple axes, like it was experimenting with how to move. Telescopes caught faint shifts in trajectory, not large, just subtle arcs, enough to suggest control, or at least reaction. And here's where the absurd thought sneaks in. What if it's not out of control at all? What if the tumble is control a pattern too complex for us to decode? Motion used as communication, like a semaphore of rotation, signaling through spin instead of sound. You can picture it, a cosmic distress call, or maybe a rehearsal. Watch me move, it seems to say, and see if you can keep up. Somewhere in the middle of that motion, new spectral lines appear. The surface chemistry changes not because of sunlight, but because of friction. Internal heat builds. The crust melts and refreezes, forming glassy scars. Its tail begins to emit polarized light, the kind that implies structure, perhaps crystalline dust aligned by magnetism, or something stranger. Astronomers start using metaphors to stay sane. One calls it a coin deciding it's tired of flipping. Another, more poetically, calls it a slow-motion panic attack. But you lying there listening to this, feeling the room dim, know what it really is. It's motion learning about itself. It's entropy rehearsing meaning. It's a traveler remembering that stillness is not survival. Hours stretch into days. The tumble continues, steady but chaotic, like a heartbeat that refuses rhythm. Then, without warning, the spin slows, just a little. Instruments catch it first. The frequency drops. For the first time in weeks, 3I Atlas seems to take a breath. And in that pause, the brief stillness between rotations, the universe feels heavier, as if everything is waiting for what comes next. Because when an interstellar traveler stops tumbling, it's never by accident. Let's linger in the aftermath, where collision turns to conversation. The void is never truly silent. It just speaks in slower languages. Out here, where gravity forgets itself and light takes its time, The remnants of 3I Atlas and its silent partner begin to mingle. Their meeting wasn't a catastrophe. It was chemistry with a sense of occasion. When two interstellar objects collide, they don't just shatter, they exchange stories. Minerals, isotopes, and frozen gases from two separate star systems now mix together in the cold vacuum. The debris cloud that formed was a chemical handshake between worlds that had never met before, and likely never would again. You imagine being close enough to see it, two clouds of matter interlacing like ghostly ink in water. The particles shimmer where they meet, tiny sparks of static gliding over crystal surfaces. If you could reach out, you'd touch the residue of two suns, each carrying secrets from its birth. It's not violence, it's intimacy, at cosmic scale. Scientists on Earth watch the collision's aftermath unfold in data points and spectral signatures. But to you, it's something else entirely, the first conversation between strangers in billions of years. The molecules are not random. They react, fuse, create hybrids that never existed before. A pinch of carbon from one star, a dusting of magnesium from another. Together, they become something new, an element of both, belonging to neither. It's tempting to think of this as cosmic gossip. One ancient traveler whispering to another, "You wouldn't believe what happened in my system." The other nods, sharing its own tale through ions and vapor. The dialogue is long, patient, wordless, but undeniably alive. The telescopes catch the signatures. Complex hydrocarbons begin to appear, molecules associated with prebiotic chemistry, the kind that make biologists raise their eyebrows. The collision, brief as it was, has kindled something: warmth, reaction, possibility. For the first time, 3I Atlas isn't just reflecting light, it's making it. The debris cloud expands slowly, a vast shimmering veil spiraling across millions of kilometers. Dust grains coated in carbon compounds drift outward, tiny black seeds sown by accident. You could call it cosmic composting, death-feeding creation, chaos giving birth to order. And yet, something strange happens. The cloud doesn't disperse randomly. It remains cohesive, swirling, as if guided by an invisible hand. Not gravity, it's too weak out here. Not magnetism, the field is too faint. But still, the particles orbit one another, forming filigree patterns, curling into halls and rings. To the human eye, it looks like art. To the instruments, it looks like defiance. Back in the control rooms, scientists argue over data. Electrostatic cohesion, one insists. Optical illusion, says another. But a few stare longer, noticing symmetry. The rings aren't random. They're evenly spaced, harmonically aligned. Patterns fractal, repeating, deliberate. What if, some wonder quietly, the collision didn't just blend matter? What if it transferred memory, physical information, encoded in structure, like a fossil of thought? It sounds absurd, of course. Rocks don't remember. Yet on quantum scales, particles can store imprints of the conditions they formed in the temperature, radiation, magnetic field, even the decay patterns of nearby isotopes. A sophisticated enough being could read that information, like reading the scars on bone. And here, in the shimmering dust, those scars are glowing. You can almost imagine it. Two objects from different origins colliding and sharing their atomic autobiographies. This is what my star looked like. One atom hums. Here's the rhythm of my orbit, another replies. It's the universe's version of swapping baby photos. But the deeper scientists look, the stranger it becomes. Within the cloud's inner ring, the chemical composition changes abruptly from carbon-heavy compounds to silicates and trace metals in ratios that mimic planetary crusts. That shouldn't happen. You don't get planetary chemistry in deep space. Unless, of course, one of the colliding bodies was carrying pieces of a world that once existed. It's a quiet realization, the kind that doesn't need to be shouted. Somewhere in this swirl of dust are the ashes of a planet that never knew we'd exist to notice it. A world that lived, died, and was scattered, and now, by sheer chance, has touched ours. As 3I Atlas spins, the cloud trails behind it like a luminous scarf. The newly fused material begins to orbit its body, forming a faint ring system, temporary, delicate, but real. The light from the sun refracts through it, painting halos of pink and green across the void. The sight is haunting, like a stained glass window built by accident in space. From afar, telescopes record the glow. It pulses faintly, not unlike the heartbeat seen before, but softer, now slower, gentler. The rhythm has changed. Perhaps it's cooling, or perhaps it's listening, because if collisions are conversations, then echoes are what happens when one side falls silent and the other tries to remember what was said. And out there, beyond the orbit of Saturn, 3I Atlas drifts onward, carrying in its dust the voices of two long-forgotten stars, still whispering to each other as they fade into the dark. Let's come back down to Earth for a moment, though. Down feels like the wrong word when every telescope is pointed up. It's late, and the world's observatories are glowing like scattered fireflies. Behind every one of those domes, someone is awake, bleary-eyed, and slightly terrified of what the universe just did. Sleep is optional when the sky starts misbehaving. For nights after the event, observatories around the world watched the faint trail left behind. Some thought it was just outgassing. Others thought it was artificial, a glimmer of structure, perhaps rotation too precise to be random. And though no one said it out loud, everyone was thinking it. What if it wasn't just rock? You can almost feel the tension through the screens. In Chile, the Atacama Array hums softly under the desert cold. In Hawaii, the Keck Observatory sits above the clouds like a sleepless mountain spirit. In Spain, telescopes turn in perfect coordination, like synchronized swimmers chasing a ghost. Everywhere, humans peer through lenses, chasing the same faint smear of light, and none of them are quite sure what they're looking at anymore. The data trickles in, light curves, spectra, motion telemetry. Nothing matches the models. The brightness pulses at regular intervals, yet the timing doesn't align with its spin. Some wavelengths are missing, absorbed by materials no one can identify. It's as if 3I Atlas has become a magician, showing its audience only what it wants them to see. In Cambridge, a professor stares at a monitor with the patience of a stone. "If it's natural," she murmurs, "it's the strangest natural object we've ever seen." Her graduate student nods, pretending to agree while quietly recording another anomaly. In Pasadena, someone mutters, "It's mimicking rotational symmetry, but only when we're watching." The room goes quiet after that. The problem isn't the data. The problem is the implications. If the brightness oscillations are too clean, that means order. And if there's order, there's intention. No one wants to be the first to say that. In a peer-reviewed paper, coffee becomes a coping mechanism. At some point, science shifts from precision to caffeine and faith. The night skies are cold, but the control rooms are warm, humming with quiet panic disguised as professionalism. Every keystroke sounds louder than it should. Someone jokes. Maybe it's just showing off. No one laughs. The silence feels heavier than gravity. The images coming in from the Hubble telescope show something faint, a shimmer that shouldn't be there. The tail of 3I Atlas is bending slightly, curving against the direction of solar wind. It's not possible, unless Of course, it's under its own control. There's an unspoken rule in astronomy: never assume intention. The cosmos doesn't mean to do things, it just does them. But as the light pulses from 3i Atlas continue, rhythmic and unrelenting, that rule starts to fray. Some researchers cling to natural explanations: volatile compounds venting periodically, or reflective ice crystals, creating a false sense of timing. Others whisper about the artifact hypothesis. The term feels radioactive, whispered only at 3 a.m., between yawns and nervous laughter. And then, the oddest thing happens. Different observatories, thousands of miles apart, begin reporting synchronized anomalies. The light pulses appear at slightly different times, but when adjusted for distance, they align perfectly. A global heartbeat, faint but deliberate. The network of watchers grows. Amateur astronomers join in, recording faint time-lapse streaks from their backyards. Forums light up. Conspiracy channels explode. For every theory, 10 more appear. It's a ship. It's a probe. It's a weapon. It's just a rock having an identity crisis. But deep in the observatories, the professionals keep watching, tired, hungry, determined. Not because they think it's alien, but because they can't stop asking why. You can imagine them, staring through the long hours, faces lit by monitor glow, notebooks filled with scribbles, equations running out of margin space, each one hoping the next frame will make sense of the last, each one knowing it probably won't. By the third night, a pattern emerges. The pulse timing correlates with a slight oscillation in position, a kind of micro-adjustment, like the object is trying to stabilize itself. It's small, almost imperceptible, but unmistakable. Something, or some process, is keeping 3i Atlas intact, and this is when the insomnia sets in. Because the moment you realize the data might be intentional, sleep becomes impossible. You start hearing rhythms everywhere, in the hum of the air conditioner, in your heartbeat, in the tick of the telescope's tracking motor. It's as though the universe is whispering, "Stay awake. You'll want to see this." By dawn, when the stars fade and the monitors go grey, the astronomers are ghosts themselves, drifting, caffeinated, half believing. They exchange glances that mean, "We saw something," but no one dares to define it. Reports start forming. Unusual photometric behavior continues. Possible spin stabilization event. The words are calm, clinical, perfectly deniable, yet behind them lies a shared unease, the feeling that the sky has started to look back. One weary scientist types into her nightly log before leaving the observatory. If it's not alive, it's doing a very good impression. And with that, she turns off the light, knowing full well she won't sleep. Because once you suspect the dark might be watching you, dreams stop feeling safe. Let's shift the scene to Earth again, to a conference hall, humming with fluorescent lights, coffee breath, and academic tension so thick you could chart it. Geneva, early morning. A city that thrives on order is about to host an argument the universe never asked for. The world's brightest minds have gathered to make sense of something that doesn't make sense, which is, of course, their favorite hobby. At an emergency symposium in Geneva, a young astrophysicist presented a wild idea. The impact wasn't an accident. What if one object had targeted the other? The older scientist chuckled, then stopped when the math matched. The two had intersected at such a precise angle and speed that it defied statistical chance. It was either the universe playing darts or something more deliberate. You can imagine the moment. The room was a sea of grey hair and cautious egos, laptops glowing like low fires. The presenter, mid-30s, Nervous smile. One coffee, too many clicked to the next slide, revealing a simulation. 2 orbits, one from our system, one from the void, intersecting perfectly in a point smaller than a human heartbeat. Random probability, she said, is less than 1 in 4 trillion. Silence. The kind that usually comes after someone swears in church. One professor shifted in his seat, another cleared his throat. The international signal for, "I'd like to disagree, but not yet." Then came the laughter, polite at first, then fading as the numbers rolled out. The simulations all said the same thing. The collision wasn't chaotic. It was orchestrated. You can see the slides in your mind. A trajectory map that looks less like a natural scatter plot and more like choreography. The vectors align, the velocities harmonize, the paths of both objects curve toward each other, as though nudged not by gravity, but by design. "Coincidence," muttered one senior scientist, tapping his pen. "Nature is full of them." "Not that full," someone replied. And that's when the room split. Half of them clung to the comfort of physics chaos, probability, entropy, all the usual bedtime stories for scientists. The other half leaned in, whispering about control, signal response, and intentional collision. You can almost hear the shifting of chairs, the shuffling of certainty. The young astrophysicist, Dr. Alina Varga, stood her ground. She showed the angular momentum data, the deceleration profile, the chemical trail of impact that suggested alignment, not randomness. "If this were 2 natural bodies," she said, "we'd expect grazing, fragmentation. But this looks like docking. The word hung in the air like a spark near hydrogen. Reporters in the back scribbled furiously. One of them tweeted the phrase before anyone could stop him. Within an hour, number cosmic docking was trending worldwide because nothing fuels public imagination like scientists losing sleep. But inside that Geneva hall, things were more complicated. Models were run live on stage, equations updated mid-sentence. One simulation, using revised parameters, showed the 2 bodies intersecting at a trajectory within half a degree of perfect perpendicular alignment. "That's not gravity," muttered a researcher from MIT. "That's geometry with purpose." Another voice rose from the back, calm, skeptical, older. "You're assuming intention because you want a story," he said. "But the universe doesn't owe us one." That line drew a laugh, not because it was funny, but because it was safe. It reminded everyone of their place. Small minds under a big sky. And yet, no one could unsee the precision. No random drift should produce this kind of harmony. By the time the session ended, the conference hall had become a fault line. One side called it the targeting hypothesis, the other mathematical mirage. Coffee breaks turned into debates, friendships frayed, entire research departments quietly picked sides. Outside, Geneva went on pretending it was still normal trams, gliding past lakes, diplomats shaking hands, the Alps gleaming in smug indifference. But inside that hall, humanity's relationship with coincidence had changed. One of the attendees, an old orbital dynamicist, wrote later in his notes, "If this was chance, it was the kind of chance that writes poetry." That night, Dr. Varga sat alone in her hotel room, laptop still open to her simulation. The data points glowed faintly, tracing 2 perfect arcs converging on a single, impossible instant. She zoomed in, frame by frame. At the exact millisecond of collision, both vectors curved just slightly, but enough. As if, at the last possible moment, they had adjusted for each other. She leaned back, whispering to no one. "You saw it too, didn't you? Somewhere beyond Jupiter, A faint light flickered once, as if in answer. Let's step back into the quiet hum of late-night observatories, where glowing monitors are the only light and every keystroke sounds like a prayer. There's no storm, no explosion, just data, trickling in like whispers. The numbers dance across the screen, small and patient, and then, one night, they start to dance together. The light curve, the graph, showing how brightness changes over time, began to behave oddly. Instead of fading smoothly, it pulsed, periodic, rhythmic, and precise. The pattern looked eerily like a signal or a heartbeat. In scientific terms, that meant nothing. In human terms, it meant everything. At first, no one wanted to believe it. Comets flicker all the time. Their surfaces are irregular, their tails unpredictable. But this was different. The timing was too clean. Every 6 hours, the brightness rose sharply, then dimmed, then rose again. Like clockwork, except there are no clocks in space. In Chile, the Atacama Array caught it first. The readings came through at midnight, a series of peaks so consistent they looked artificial. The operator frowned, assuming a calibration error. "Must be an internal reflection," he muttered. But when he cross-checked with Japan's Subaru telescope, the pattern was identical. 2 instruments, 2 hemispheres, 1 pulse. Imagine it, a single point of light, billions of kilometers away, flashing like the smallest, loneliest lighthouse in the universe, each pulse lasting a few minutes, faint but stubborn, too deliberate to ignore. You can almost see the researchers leaning in, breath held. "It's just rotational brightening," says one voice. "Surface albedo variation," says another. Science loves an explanation, even when it's whispering over the sound of its own heartbeat. But then the rhythm changes. Not much, just a fraction of a second off. Enough to be noticed. Enough to imply intent. Data analysts run Fourier transforms, looking for hidden frequencies. What they find makes the room go silent. The intervals between pulses are not random noise. They form a repeating ratio: 3, 1, 2, 1, 3. The kind of pattern nature rarely bothers with unless it's building something. The discovery spreads quietly through encrypted emails and late-night calls. "Are you seeing this too?" one astronomer asks another, voice trembling just slightly. The replies all come the same: "Yes, and I don't like it." Soon, the international observatories form a collaboration, unofficial at first, then formal enough to get its own acronym: LCTP, the Light Curve Tracking Project. They assign shifts, schedule cross-checks, compare timestamps. No one says, "Signal," not yet, but they all think it. The media, as always, finds out anyway. Someone leaks the graphs. Within hours, headlines scream, "Heartbeat in deep space. Is 3i Atlas trying to communicate?" Astronomers detect rhythmic pulses beyond Saturn. The scientists groan, roll their eyes, and keep working, because the truth is both more boring and far more terrifying. If this isn't communication, then something in the laws of physics is misbehaving. Night after night, they record more data. The light pulses continue, unwavering. The intervals grow slightly shorter, as if whatever's causing them is accelerating. A few researchers start to treat it like music mapping the brightness to sound frequencies. When played through speakers, it produces a low, haunting rhythm, a steady, slow thump, almost alive. You imagine listening to that sound in the dark. Not a song, not a code, just something breathing, faintly, across a gulf of space so wide it can't possibly matter, and yet somehow it does. By the 3rd week, theories multiply. Some claim the pattern is caused by a binary nucleus, two cores rotating around each other. Others suggest the pulses are chemical, the product of exotic outgassing. But no model fits perfectly. Every explanation feels like an apology. In the meantime, the rhythm continues slow, patient, uncaring. Every 6 hours, a pulse. Every pulse, a question. A few bold minds begin testing the unthinkable. They send out their own pulses, radio signals timed to match the object's rhythm, just in case. A cosmic knock on the door. Of course, there's no answer. There never is. But that doesn't stop them from listening harder. And then one night, the rhythm skips. Not a failure, a change. Two pulses come close together, followed by a long pause, then 3 quick bursts. When plotted, the light curve forms a shape eerily familiar. 2 short, 1 long, 1 short. Morse code for H. Coincidence, say the skeptics. Confirmation bias, say the cautious. But the room has gone too quiet for denial. Everyone watching feels it, that creeping chill at the base of the spine that comes when the universe stops behaving like a background and starts acting like an audience. Dr. Varga, still the center of this growing storm, writes in her logbook, "The pattern persists. No known natural mechanism. I know I should sleep, but if I blink, I might miss what comes next." She doesn't sleep. None of them do. Out there, beyond Saturn's orbit, 3i Atlas keeps pulsing steady, unhurried, calm. Whatever it's doing, it's not done. And for every human staring up at those tiny flickers of light, the question grows heavier. Is this data? Or is this dialogue? Let's step quietly back into the dark, that immense, patient ocean where silence has weight. Out there, where even light takes its time, the debris of 3i Atlas drifts like ash after a funeral. 1,000 pieces of glittering stone, each one ancient, indifferent, free. At least, that's what everyone assumed. Because debris, by definition, doesn't organize itself. When telescopes zoomed in on the debris field, they noticed something odd. Not all the fragments were drifting away randomly. A few seemed to be moving together. Tiny, synchronized glints traveling in formation, maintaining distance, accelerating slightly, like they had somewhere to be. At first, astronomers dismissed it as an illusion. Light can play tricks, especially when your eyes are tired and your data is grainy. Cosmic dust dances in currents you can't see, radiation pressure, magnetic fields, solar wind. There's chaos out there, and chaos is easy to mistake for intention. But chaos doesn't hold formation. So they zoomed in again. And again, the Hubble images were blurry, but something strange appeared between the pixels. Faint lines of reflected light, aligned too perfectly to be random. It looked almost mechanical, as if shards of 3i Atlas had agreed on choreography. 3 glints, always 3, equidistant, spaced a few hundred meters apart, rotating slowly around an invisible point, like satellites around a ghost. At the European Southern Observatory, the first person to notice it, a sleep-deprived intern named Raphael, assumed he'd made a data error. He reran the imaging software. The pattern remained. He called in his supervisor, who frowned and said, "That's odd," a phrase that, in astronomy, means someone's about to ruin their career or make history. Soon, other telescopes confirmed it. The shards weren't drifting apart. They were maneuvering subtly, consistently, defying the random chaos of collision debris. "It's probably magnetic," someone suggested. "Maybe they're ferrous and aligning with the solar field." But the motion was too coordinated. The spacing didn't change. The orientation didn't wobble. It was precision, mechanical, deliberate. The fragments seemed to accelerate in small bursts, matching the direction of three I-Atlas's remaining core, which itself was still tumbling, still pulsing faintly. It was as though the shards were following it, escorts to a wounded traveler. You can picture it. Three glittering motes, drifting silently across the black, reflecting the pale sunlight of a distant star, each one tiny, yet moving in step, like the faint rhythm of a heartbeat carried into motion. If you squint, or if your imagination is still awake, you might even think of fireflies over an endless ocean, never touching, never lost. Scientists, of course, refused to romanticize it. They built models instead. Orbital resonance, one claimed. Electrostatic binding, said another. Coincidence, insisted the older ones, who preferred their universe comfortably meaningless. But then the velocity data came in. The shards weren't just maintaining formation, they were accelerating. Slowly, imperceptibly at first, but undeniably increasing speed. Radiation pressure couldn't account for it, nor could outgassing or residual momentum. The direction was wrong. The timing was too precise. And that's when the whispers began again. What if it's not debris? Someone asked during a midnight teleconference. What if it's function? The silence afterward was almost reverent, the kind that fills a room when people realize they've stepped across an invisible line from science into story. Dr. Varga, still watching from Geneva, stared at the light curves on her monitor. The three glints pulsed faintly, echoing the same rhythm as the original three I-Atlas heartbeat, but out of phase, offset by seconds. As if replying, she whispered, "They're answering it." Her colleagues tried to reason it out. Maybe the rotation of the parent body was creating periodic radiation pressure. Maybe fragments had formed stable orbital pairs. Maybe. But each theory died the moment new data came in, because now there were four glints. A fourth shard had joined the formation, smaller but perfectly aligned. Whatever was happening wasn't fading, it was spreading. The fragments, barely visible even to Hubble, were now detectable through their reflections in solar radiation. They formed a diamond shape, a geometry too simple to ignore. Not random, not chaotic, purposeful. Could they be pieces of a single structure? Asked one analyst. Something that broke apart and is reassembling. No one wanted to answer. If you could see it from up close, you might think of clockwork, shattered gears, slowly finding each other again. Or like migratory birds, reforming their pattern after being startled. It wasn't speed that mattered anymore. It was precision. The universe had become a stage for something rehearsing. Over the next few nights, the formation held. No drift, no spin, no decay, just steady, silent motion through the cold. When plotted, their trajectory wasn't random either. The shards were following a curve, not the one dictated by the sun, but by something deeper, something almost self-correcting. Meanwhile, back on Earth, the data reached the media. The headlines were, as usual, both too much and not enough. Alien debris, flying in formation, fragments of three I-Atlas defy gravity. Scientists stumped by March of the Shards. And though every expert interview was careful to deny anything sensational, none could deny the facts. Four fragments, moving in tandem, accelerating in unison. By the fifth night, they began to blink, not randomly in intervals matching the heartbeat pattern first recorded weeks ago. One pulse from the main body, then four responses, delayed by exactly 2 minutes. 5 lights, speaking softly across space. To anyone watching, it looked like a conversation. Let's move closer again, not through space, but through the spectra, those shimmering rainbows of data that turn light into confession. Every glint, every photon reflected from 3I Atlas and its strange, loyal shards is a sentence in a language written by atoms. And tonight, the universe is saying something it's never said before. Spectroscopic analysis revealed something that didn't belong. Heavy metals forged in conditions no known star system could explain. Not radioactive, not natural. Some theorized it was artificial alloy, the kind humans dream of using for spacecraft hulls. Others said it was a coincidence of chemistry. Both groups agreed on one thing: the data didn't fit. The first clue came from a line that shouldn't have existed, a spectral spike deep in the infrared, where no known compound glows at that temperature. It was faint, but persistent, like a whisper that refuses to stop once heard. Every telescope that turned toward 3I Atlas saw the same thing, a strange alloy shining where there should have been ice. You can imagine the lab rooms where the discovery broke cold light, tired faces, the hum of supercomputers chewing through starlight. A grad student in Arizona first noticed the anomaly, mistaking it for sensor noise. She almost deleted the data, but then she cross-referenced it with the European Space Observatory's readings, and there it was again, a line at 12.1 microns, clean and deliberate. No one could explain it. The ratio of absorption bands implied an element combination that didn't exist on the periodic table. Not alien, exactly, just too perfect. A lattice of metallic bonding that implied design. If you were an engineer, you'd call it an alloy. If you were a physicist, you'd call it a problem. Soon, labs from Tokyo to Pasadena joined the hunt. Data was traded like contraband encrypted files labeled Noise Study 13 and Null Ref Atlas. Inside those files were spectra that refused to behave, peaks too sharp, valleys too symmetrical, a material that seemed to reflect radiation selectively, as if tuned to certain frequencies. Imagine a mirror that only reflects specific songs. That's what this was. A metal that hummed when it should have slept. To most, the simplest answer was chemistry, some unknown mineral mixture born under exotic pressures. But the more they tested the models, the stranger it got. The isotopic ratios suggested a forging temperature well beyond that of any known star, and far too controlled to be random. It was as if the atoms had been told where to go. Someone at NASA half-jokingly said, "Well, that's one way to 3D print a comet." The joke didn't land. In a Zurich lab, a materials scientist noticed something even stranger. The alloy's reflectivity changed depending on the angle of observation. Not in the usual way, not like polished metal. It shifted patterns. Under certain polarizations, the spectral lines rearranged themselves, not randomly, reversibly. When she overlaid the data, the pattern looked almost digital, repeating intervals that could, in theory, encode information. Her colleagues told her to stop anthropomorphizing chemistry, but she didn't. She started decoding it. The first few attempts led nowhere. Noise, static, nonsense. But one iteration produced a shape, a repeating hexagonal motif, symmetrical and layered, too precise for coincidence, too organized for chaos. She sent the results to Dr. Varga in Geneva, who had by now become the reluctant curator of everything that refused to make sense. Varga stared at the images for hours. The hexagonal lattice pulsed faintly, frequency shifting as though reacting to its own observation. "It's adaptive," she whispered. That word adaptive became the lightning rod. Some dismissed it instantly, others clung to it. Adaptive material, smart alloy, self-regulating metal. The papers flooded in. Every theory contradicted the next, and all of them agreed on one uncomfortable truth. This wasn't standard astrophysics anymore. One team even proposed a horrifyingly elegant theory that 3I Atlas wasn't carrying metal from another world, but had become one, a body whose interior had transformed under alien chemistry, evolving over time like a metallic organism. If that sounds ridiculous, remember this object had already survived collision, pulse, and reassembly. Ridiculous had left the building a long time ago. Meanwhile, the shards still moving in formation began to glow faintly with the same spectral signature. The alloy wasn't just on 3I Atlas anymore. It was spreading. The fragments' surfaces shimmered with identical wavelengths, as though sharing information through light itself. When scientists tried to model it, their software crashed repeatedly. The code that described the material would eventually loop into infinite recursion, as if the math couldn't settle on what the alloy was. One researcher summarized it best. It's like trying to describe a mirror that reflects itself forever. You can picture the sleepless faces, the blinking cursors on screens, the equations written and erased until the chalkboards looked like haunted murals. And somewhere between exhaustion and awe, someone finally said what no one wanted to. What if it's not a fragment of something built, but a fragment of something alive? The silence after that stretched longer than the distance between stars. Back in space, the alloy shimmered on, indifferent to human panic. The shards turned slowly in formation, catching sunlight and releasing it as infrared hums. A cosmic fingerprint, or perhaps a signature. And if you're listening closely, if you imagine yourself drifting beside them, you can almost hear it, a faint metallic whisper in the dark, saying, "I remember where I came from." Let's float now into the quiet, measured heart of motion, where speed is only half the story, and direction is the part that makes scientists sweat. Out here, everything obeys gravity. It's the one rule the universe never bends. Every rock, every moon, every lonely scrap of cosmic dust falls along its invisible threads. But now, one of those threads has gone slack. Weeks later, 3I Atlas began to drift off its expected path. Not a lot, just enough to ruin every model. Its velocity vector shifted subtly, like it had fired invisible thrusters or caught a gravitational current that wasn't there. Even space agencies recalculated, blinking at the numbers. It wasn't falling, it was steering. At first, no one wanted to say it. Words like maneuver and course correction are for spacecraft, not comets. They imply agency, and agency means someone or something made a decision. But the numbers didn't care about semantics. The first deviations appeared small, less than 0.05 degrees from its projected trajectory. Then, over the next few nights, the deviation widened. Nothing catastrophic, just enough to feel deliberate, as though 3I Atlas had decided that physics was a suggestion, not a law. You can imagine the scene in mission control rooms around the world. Screens filled with orbital diagrams that no longer lined up, engineers holding their heads, and somewhere in the back, one intern whispering, "It turned." The word felt like a betrayal. In Pasadena, NASA's Jet Propulsion Laboratory ran simulations all night. Solar radiation pressure, someone argued. Maybe asymmetric outgassing, the usual culprits. But the math betrayed them again. Outgassing causes random drifts, a push here, a wobble there, not steady acceleration along a curve. Across the Atlantic, the European Space Agency ran their own models. They fed in every variable they could imagine: mass distribution, temperature gradient, spin orientation. The output came back with an error message no one had ever seen before. No stable solution. Somewhere, quietly, a systems engineer muttered, "It's steering." No one contradicted him. The object's motion began to show rhythm, minute bursts of change, spaced hours apart, consistent with the pulsing patterns first detected in its light curve. The scientists who'd tracked that heartbeat months earlier stared at the telemetry in stunned silence. Each pulse corresponded perfectly to a shift in trajectory. It was subtle, elegant, terrifyingly controlled, like a whale adjusting its course with the flick of a fin. At first, the acceleration pointed it slightly inward, toward the sun, a suicidal path for ice and dust. But then, just as the heat should have torn it apart, it veered again, slingshotting outward with impossible precision. It wasn't reacting to the sun's gravity, it was using it. For the first time, humanity watched a rock fly like it knew how. The official statements were, as always, sterile. NASA called it a non-gravitational trajectory modification. ESA said, anomalous motion, likely due to outgassing asymmetry. The public heard what they wanted to. The comet is alive. Conspiracy theorists rejoiced. Engineers frowned. Astronomers lost sleep. Meanwhile, the data kept coming. Each change in velocity was precise, consistent with deliberate micro-adjustments, bursts of acceleration, followed by perfect stabilization. Whatever 3i Atlas was doing, it wasn't random, and it wasn't overreacting. It was calm, methodical, confident. Dr. Varga, by now the weary caretaker of cosmic unease, described it best. It's not panicking, it's navigating. The phrase caught on like poetry. Telescopes followed the new path, a long, graceful curve, leading outward and slightly north of the ecliptic plane, not toward any known destination, just away. Away from us, away from the sun, away from everything. But if you extended the curve far enough, it intersected the approximate vector of another star system, one about 12 light-years distant. Coincidence, said some. Navigation, whispered others. Then came the shock. As 3i Atlas altered course, the 4 shards trailing behind it, the fragments that had moved in formation for weeks adjusted too. They mimicked its shift within hours, their alignment holding perfectly, not reaction, synchronization, like a school of fish turning together in silence. And still, no visible propulsion, no jets of gas, no exhaust, nothing, just movement, quiet and precise. It didn't take long for the equations to betray something else. Energy. The change in motion required an output that exceeded what solar radiation could provide by several magnitudes. The object wasn't being pushed. It was choosing. Back on Earth, agencies began quietly competing to explain it. Theories bloomed like algae electromagnetic sails, quantum propulsion, natural dark matter pockets, each more desperate than the last, none satisfying. In private calls and encrypted channels, the question repeated like a heartbeat. Is it responding to something? No one could prove it. But when they plotted the new course alongside old data, back to the collision, back to the flash, they noticed a haunting symmetry. The trajectory of 3i Atlas's new path formed a mirror of the angle at which it was struck. It was retracing the impact, as if whatever hit it hadn't just changed its spin, it had taught it where to go. You can picture it now, a single, luminous traveler, bending its way through the dark, its fragments in perfect step behind it, not drifting, not falling, steering with purpose, patience, and a rhythm too ancient for panic. And maybe, just maybe, it's heading home. Let's slip now into wavelengths we can't see, into the part of the spectrum that feels like breathing more than seeing. The visible light was gone, the shimmer of reflected sunlight fading as 3i Atlas sailed farther from the Sunday. But telescopes didn't stop watching. They just changed how they listened. They tuned to heat, to whispers. And that's when the universe spoke again. Then came the strangest reading of all. A faint infrared pulse, regular, repeating, consistent with heat cycles. It looked like a cooling mechanism, a release pattern, almost deliberate. The signal was faint, lost amid background radiation, but the rhythm matched the light curve from before. Infrared telescopes are like eavesdroppers for warmth. They can hear the sighs of stars and the ghost heat of asteroids. What they caught from 3I Atlas wasn't a sigh, it was a heartbeat. The same spacing, the same pattern, but softer, like the same voice, now whispering. At NASA's Deep Space Infrared Array, the data came through in pale orange bands. Thermal modulation detected. Read the log entry. Amplitude, consistent with engineered dissipation. That word engineered shouldn't have been there. It wasn't an official term. Someone typed it and left it anyway. When they plotted the pulses over time, the line wasn't random. It rose and fell like breathing. Every pulse followed a consistent energy curve. Build, release, stabilize. It looked like a cooling cycle. It looked like control. You can imagine the engineers staring at the thermal graphs, the glow of their screens reflected in their tired eyes. Someone says, "It's venting heat." Someone else whispers, "From what?" Normally, comets radiate heat unevenly as they spin, sunlight cooking one side, freezing the other. But this wasn't sunlight. The pulses came from deep inside the object, periodic, measured, almost mechanical, and there was the rhythm again. 6 hours, then a pause. 6 hours, then a pause. The same timing as the optical heartbeat from weeks earlier. Only now, in the infrared, it was clearer, like a conversation that had dropped to a whisper but hadn't stopped. One analyst tried to dismiss it. "Could be internal stress fractures," she said. "Thermal expansion and release." She sounded confident until someone plotted the temperature differential. The heat wasn't dissipating randomly. It was moving, slowly, in a spiral pattern around the body of 3I Atlas, as though guided by design. Someone else joked, "Maybe it's stretching." No one laughed. As the object drifted outward, away from the warmth of the sun, the heat cycles didn't fade, they strengthened. Against every model, against thermodynamics itself, 3I Atlas was warming up. By now, the data had become a symphony of confusion. The optical pulses matched the infrared pulses. The shards moving in formation began to echo the same rhythm, faint but measurable. 5 distinct sources, all pulsing in the same 6-hour cadence, coordinated across millions of kilometers. When scientists overlaid the data, visible light, thermal, motion, they formed an eerie alignment. Each pulse of light corresponded to a burst of infrared, which corresponded to a micro-adjustment in trajectory. In simple terms, it flashed, it exhaled, and then it moved. To call that natural was like calling jazz an accident. Somewhere in a quiet corner of Geneva, Dr. Varga stared at the combined data set and whispered, "It's talking to itself." And maybe it was. The infrared signature wasn't random noise, it carried modulation, subtle variations between pulses, like syllables. Each emission had slightly different intensities, distributed along a harmonic curve. In other words, it wasn't just breathing, it was saying something. The SETI Institute, the people who usually spend their lives listening for aliens in radio, got involved next. They weren't supposed to. Infrared isn't their domain. But someone forwarded them the heat data, and within hours, they were analyzing it like a new kind of message. They found nothing conclusive, of course. No binary pattern, No obvious code, just repetition, just rhythm. But humans are meaning-seeking creatures, and rhythm is enough. Rhythm makes us think of music, of pulse, of life. So they kept listening. The next week, a new anomaly appeared. The infrared pulses began to shift in timing, gradually shortening by fractions of a second. It was as though the heartbeat was quickening, or tuning itself. The temperature at the surface of 3I Atlas rose slightly, just a few degrees Kelvin. But that increase, over such a short timescale, was unprecedented for an object that far from the Sunday. It was like watching a frozen boulder decide to get comfortable. Speculative papers appeared overnight. Autonomous thermal regulation in interstellar objects, non-gravitational propulsion via thermophotonics, self-heating as signal encoding. The theories were endless, contradictory, and all slightly terrified. And yet, through all the noise, one observation stood alone. The heat release wasn't random, chaotic, or degrading. It was efficient, purposeful. The way a spacecraft might release built-up energy to stabilize temperature or conserve power. The final frames from the James Webb Space Telescope confirmed it. The pulses were propagating through the shards as well, like a synchronized network. 5 heat sources, 5 pulses, 1 rhythm. The universe doesn't build thermostats, but maybe something in it does. Back on Earth, under normal skies, people who never cared about astronomy began to check the night. Not because they expected to see anything, but because knowing something out there was breathing was oddly comforting and deeply unnerving. And if you listened closely, not with your ears, but with that quiet part of you that still remembers awe, you could almost hear it too. A slow, patient hum rolling through the dark, pulsing from a traveler older than history. The whisper from infrared, a sigh from the void, a machine, or maybe something more remembering how to stay alive. Let's drift back down to Earth, where silence is a luxury and attention is the loudest currency. For months, 3I Atlas had belonged to scientists. Quiet nights, long calculations, careful language, but then someone leaked the data. One headline, one rumor, one irresistible word, artificial, and suddenly, the cosmos had an audience it never asked for. Once the public caught wind, everything changed. Headlines screamed, alien probe, hit by unknown object. Conspiracy channels erupted. Scientists begged for patience, for peer review, for calm. But humanity doesn't do calm well. Every telescope pointed upward. Every night, more people watched the sky for a glow that would never reach their eyes. You can picture it, the chaos of certainty. Morning shows with glittering graphics and expert panels made of science communicators, ex-astronauts, and people who once owned telescopes as children. The anchors smiled too brightly. "Is this our first contact?" they asked, like they were talking about a celebrity engagement instead of an existential crisis. Twitter, or whatever name it had, now burned for weeks. Threads of speculation stretched longer than the comet's tail. "It's a weapon," said one side. "It's a rescue mission," said another. The memes were inevitable. Someone photoshopped 3I Atlas into a flying saucer with turn signals. Someone else made a TikTok claiming it matched coordinates from an ancient Sumerian star map. The video got 8 million views in 3 hours. The scientists, poor souls, were dragged into the spotlight like reluctant prophets. Dr. Alina Varga became the unwilling face of reason. Her face appeared on every news outlet, every late-night show, every conspiracy thumbnail with glowing red circles drawn around her eyes. She kept saying the same words, "We don't know yet." But uncertainty doesn't trend. In press conferences, The microphones multiplied. Dr. Varga, are we looking at alien technology? Is it moving toward us? Is it dangerous? She'd inhale, steady, and reply, we're observing an object exhibiting unexpected physical behavior. That's all. Which, of course, made things worse. The phrase, unexpected physical behavior, was exactly vague enough to terrify everyone. Stocks in aerospace companies surged. Telescope sales spiked. The Church of the Galactic Return, an old UFO cult from the 1970 seconds, reopened its website and began live streaming prayers to welcome our returning architects. In one surreal week, 3i Atlas went from anonymous rock to global myth. Politicians made statements about transparency. NASA and ESA held joint briefings that said absolutely nothing but looked very important. The Pentagon quietly formed a monitoring task force, which of course leaked immediately, fueling even wilder speculation. But the strangest reactions came from ordinary people. Families gathered on rooftops and beaches, gazing at the night sky as if expecting a sign. Teenagers uploaded shaky videos claiming to see the flicker. Street vendors sold glow-in-the-dark shirts that read, I survived the interstellar visitor. Humanity had turned awe into merchandise within a week. Through all of it, the astronomers kept working. Most hated the attention, but a few admitted the public frenzy brought more funding in 1 month than a decade of grant proposals. Telescopes once deemed too expensive suddenly had donors. Everyone wanted a piece of the mystery. Still, the pressure mounted. Every new paper was scrutinized by both academics and armchair analysts online. Every misinterpreted phrase, possible structure, thermal regulation, trajectory deviation, turned into fuel for 1,000 YouTube documentaries. Meanwhile, the actual data continued silent, precise, unyielding. 3i Atlas kept moving, its path unwavering, its pulse steady. While humanity screamed about meaning, it simply existed. Out there, in the black, the object neither confirmed nor denied anything. It just glowed, faintly, as if amused. Dr. Varga once said in an interview, it's ironic. The more people watch it, the less we understand it. It's like the universe knows we're looking and decides to blush. Her words became a quote, then a meme, then graffiti on a London underpass. The universe blushes when we stare. Governments, of course, grew nervous. Satellite networks were quietly reoriented to keep an eye on 3i Atlas. A few nations hinted at defensive postures, though no one knew what that meant against a rock moving faster than human thought. And yet, amid all the noise, something tender bloomed. People began talking about space again, not as distant trivia, but as ours, not governments or scientists or billionaires' ours. Kids asked for telescopes for their birthdays. Poets wrote odes to a comet that might be more than a comet. Couples lay in fields pointing upward, whispering, do you think it's looking back? Maybe that's what the universe does best. It humbles us, then makes us wonder anyway. By the end of the month, the media storm began to calm. Not because people lost interest, but because the story became too big to hold. It slipped into background radiation, that constant, quiet hum of collective fascination. Somewhere in the dark, 3i Atlas kept pulsing in infrared, whispering the same rhythm it always had. The noise on Earth faded, the cameras turned away, and the universe, as it often does, returned to doing whatever it was doing before we interrupted. But for one brief, dazzling moment, humanity had looked up together, not to pray, not to argue, just to wonder. And that, perhaps, was the loudest thing the void ever said. Let's descend now into the hum of machine logic. The The whirring vaults where data becomes imagination and equations become prophecy. Gone are the telescopes and press rooms. This is the realm of supercomputers. Endless racks of processors cooling themselves with the quiet sigh of artificial wind. Inside them, the universe is reborn 1,000 times a second. Each simulation, a guess at what really happened that night beyond Jupiter. Supercomputers ran endless simulations. The results showed something astonishing. The smaller object hadn't simply hit 3I Atlas, it merged with it, embedding deep inside, like a key sliding into a lock. The energy signature afterward made sense only if something had been activated, not destroyed. You can imagine the moment that realization hit. A cluster of exhausted scientists staring at screens as the simulation's final frame froze. Two trajectories becoming one, their impact curve flattening into perfect alignment. The smaller body didn't fragment. It vanished into 3I Atlas, absorbed completely. "Run it again," someone said. They did. Then again. Then another 1,000 times. No matter how they changed the input's mass, velocity, composition, the math always leaned toward the same, impossible conclusion. The event didn't behave like a collision. It behaved like integration. In the simulation, at the exact millisecond of contact, the kinetic energy signature dipped, not spiked, as it should have. It was as though the impact had been anticipated, absorbed, redirected, like a catch instead of a crash. That made no sense. Impacts don't absorb energy neatly. They dissipate it violently. Unless, of course, the body that received it was designed to do so. The scientists watching didn't say that word designed, but it hung in the air anyway, too heavy to dismiss. One physicist finally broke the silence. "It fits like an access code." Her supervisor rubbed his temples. "You mean a key?" She didn't answer. She didn't have to. The energy graphs told the rest of the story. A spike in heat, followed by rapid cooling, not decay, not explosion, stabilization. The temperature pattern resembled controlled activation, the kind seen in machine diagnostics or reactor startups. A slow climb, a plateau, a calm exhale. Someone whispered. It woke up. The phrase was met with nervous laughter, but no one found it funny, because when they ran the models backward, tracing energy flow over time, the collision began to look deliberate. The smaller body's trajectory lined up with such impossible precision that even accounting for gravitational variance, it hit the exact geometric center of 3I Atlas's spin. Not near it, not close, dead center. That precision meant one of two things. Either the universe had rolled a cosmic natural 20, or someone, or something, aimed. In Geneva, Dr. Varga and her growing, sleepless team watched the simulations in silence. Every rerun confirmed the same absurd truth. The secondary object's velocity matched perfectly with the main body's pre-impact rotation. As though synchronized, she leaned back in her chair, whispering, "Not a dart thrown at a target. Two gears meeting in motion." Her assistant, blinking at the display, murmured, "Then what did it unlock?" They didn't have to wait long for an answer. Within hours of the simulated merge, new energy readings appeared, a pattern that perfectly matched the infrared pulses detected weeks later. The heat cycle hadn't started after the impact. It had been triggered by it. The moment of contact hadn't just rearranged rock and ice. It had flipped a switch. Now, the evidence began to fall into place, one improbable piece at a time. The change in trajectory, the synchronized shards, the heartbeat-like pulses. It all traced back to that instant, the union of two ancient travelers in the dark. The new hypothesis was heretical, but irresistible. The smaller object wasn't debris. It was a component, A module, a seed, waiting for a host. Not a collision, but a completion. Across the world, research facilities began running their own reconstructions, each one returning nearly identical results. The object had slowed itself before impact. It had matched velocity. The approach vector was so finely tuned, it could only have been calculated. If 3I Atlas was a relic, the other object was its key. The international research boards tried to suppress that interpretation. Of course, press releases were careful to use phrases like kinetic absorption event or low-energy merger. But the scientists weren't fooled. The physics was too clean, too polite. Nature doesn't do polite. A private lab in Japan went further, modeling internal density changes from the merged mass. Their simulation suggested cavities forming within the main body after impact tunnels or channels radiating outward from the entry point. Structural reorganization, they called it. But the word they meant was machinery. Dr. Varga watched all this unfold, unable to shake a single, terrifying thought. What if we didn't witness an accident, but an arrival? Outside her office window, dawn broke over Lake Geneva. The world looked the same, quiet, civilized, confident in its routines. And yet somewhere far beyond Jupiter, something that had slept for eons was now awake, reshaping itself, moving with purpose. In one of the final simulation frames, just before the model crashed from computation overload, a pattern appeared, faint, circular, perfect. The merger had formed a ring, not debris, but symmetry. It's rebuilding, someone whispered, and for the first time, no one dared call that impossible. Let's return to the moment of collision, not to watch it, but to listen to what never came. On Earth, we expect drama to make noise. Thunder follows lightning, fire roars, waves crash. But the universe doesn't care about our sense of spectacle. Out there, sound doesn't travel. Chaos happens in absolute silence, and that's what makes it holy. For all the noise on Earth, the collision itself was silent. Space does that. It absorbs drama, turns chaos into quiet. No shockwave, no echo, no debris clatter. Just the stillness of momentum, two trajectories becoming one. It's strange how the universe's loudest stories always unfold without a sound. You imagine the moment, 3I Atlas, drifting through the black, and the smaller object approaching, small enough to miss, fast enough to matter. If you could watch it up close, you'd see a faint shimmer as they met, like two soap bubbles touching. Then nothing. No boom, no flame, not even a spark, just a new shape where two used to be. If you were there, floating nearby, you might not even realize anything had happened. The stars would remain where they were. The light wouldn't flicker. Yet, inside that stillness, something irreversible began. It's almost cruel, how quiet the universe is about its revolutions. Our world began in silence, two tectonic plates shifting, mountains rising, continents breaking apart beneath soundless skies. The universe writes its biggest chapters in whispers. When scientists reconstructed the event, they couldn't help noticing that the lack of noise wasn't emptiness. It was precision. The energy transfer had been perfect. No violent scattering, no waste. It was as if every joule had been budgeted, accounted for. It didn't behave like an explosion. It behaved like an equation resolving itself. That's when one of the researchers said, "This wasn't an accident. It's too quiet to be one." The silence of the collision became a mystery in itself. Normally, impacts in space leave us signature thermal spikes, light flares, chaotic debris fields. But the readings from that night showed a strange dip in background radiation, as though something had absorbed the energy instead of releasing it. A soundless inhale from an object that wasn't supposed to breathe. Across the observatories, they played back the data again and again. Nothing but static, no spike, just a small, clean absence where there should have been noise, like the universe skipping a note. If you could translate silence into meaning, it might have said, wait. The collision had rewritten not only trajectories but expectations. The smaller object hadn't shattered or bounced away, it had been taken in, consumed, if that's the right word, integrated, if you're feeling generous. One astrophysicist described it as a perfect handshake. Another, more poetically, said it was like two notes blending into one chord, too low for human ears. That silence rippled all the way back to Earth. It haunted the simulations, the models, the sleepless scientists who kept asking how something so catastrophic could be so composed. When they plotted the energy readings as a waveform, it didn't look chaotic, it looked harmonic. The frequency tapered smoothly, almost musically. Dr. Varga once wrote in her logbook, "If the universe were an instrument, this was a rest, not a crash." The pause before the melody changes. She wasn't being poetic. The silence had structure. Infrared sensors picked up a faint afterglow that rose and fell at intervals 6 hours apart, just like the later pulses. The heat wasn't random decay. It was rhythmic, controlled. Silence wasn't the end of sound, it was the start of signal. That's the paradox of 3I Atlas. The more it defied expectations, the quieter it became. Each anomaly came not with noise, but with calm, as though the object was learning how to move through the void without disturbing it. Even the shards that followed it, those faint fragments that refused to drift away, moved silently. They reflected sunlight like whispers, never colliding, never clattering, each keeping its distance as if honoring a sacred hush. Silence in space isn't emptiness, it's containment. It's energy so perfectly balanced that it cancels its own voice. And yet, humans, being what we are, can't stand silence for long. On Earth, the chatter roared interviews, think pieces, predictions, panic. But out there, in the dark, where it actually happened, everything stayed perfectly still. If you could stand beside that quiet scene, if somehow your fragile lungs could bear the emptiness, you might feel something deeper than fear. Respect. The universe doesn't shout to get your attention. It doesn't perform for applause. It just rearranges itself, in silence, and waits for you to notice. Somewhere beyond Saturn, two ancient travelers merged in complete quiet, and the cosmos held its breath. Maybe that's what awakening sounds like, not thunder, not music, but the clean, eternal hush of something remembering what it is. Let's turn our gaze now toward the most patient machine ever built, to stare into forever, the James Webb Space Telescope. Suspended beyond the moon's pull, floating in a halo of cold precision, Webb doesn't blink. It doesn't sleep. It just waits for light to reach it. Light that left its source long before your grandparents were born. But this time, it was looking for something much younger, much stranger, a traveler that didn't belong here. Weeks later, the James Webb Space Telescope finally caught up with it. It trained its mirrors on the debris trail, sifting through dust spectra. What it saw wasn't just carbon or silicates, it found trace signatures of complex molecules. Organic ones, some fragile enough that they shouldn't have survived any collision. But there they were, glowing faintly in infrared. That discovery changed everything, quietly, without headlines at first. Webb's infrared sensors detected faint emission peaks, carbon chains long and tangled, nitrogen compounds arranged like tiny lattices. Molecules usually found near the edges of life, not life itself, but the recipes for it. At first, scientists thought it was contamination. Maybe the telescope had picked up residual traces from calibration sources, a stray signal from an old comet, or even a data glitch. But when they cleaned the logs and reprocessed the data, the signal remained. The organic molecules were real, and they weren't scattered randomly. They were layered. Imagine looking into a shattered snow globe and finding that the shards are arranged by color, by design. That's what Webb saw, stratified rings of dust around 3I Atlas, each glowing with a different chemical fingerprint. The outer layers were simple water ice, silicates, ammonia. The inner layers, though, shimmered with complexity. Amino-like compounds, hydrocarbon chains, aldehydes, and something else, a spectral line that matched nothing known. It was as though the object had been painted, molecule by molecule, over time. Inside NASA's clean rooms, the data printed out as ribbons of numbers and graphs. One researcher, staring at a peak at 3.4 microns, muttered, "That's organic." Then she saw another at 4.7, one that didn't belong to any terrestrial molecule. And that's not. What Webb had found was something both impossible and familiar, a collision that created or revealed chemistry that looked almost biological. Not fossils, not microbes, not life, but the scaffolding life could use. One chemist said it best. It's like finding the ingredients of a recipe baked into the oven. When they mapped the molecules across the debris field, the pattern wasn't random. There were gradients, transitions, concentrations, as though heat and motion had worked together intentionally, layering compounds where they could best survive. The organic material was densest near the embedded object, the one that had merged with 3I Atlas. That suggested heat but not destruction, controlled reaction zones, pockets where chemistry had been shielded. In other words, someone, or something, had designed this object to protect fragile organics from annihilation. That realization sent chills through the room. Webb wasn't just looking at rock, it was looking at preservation. A fragment of interstellar space carrying organic chemistry across the void, like a seed pod, armored in metal and ice. For days, the team debated whether to go public. Organic molecules in space weren't new comets, and asteroids have carried them before. But these were different. They weren't ancient remnants. They were fresh. The spectral lines showed little radiation damage. They had been created or exposed recently, which meant that the collision, that perfect, silent impact, hadn't destroyed them. It had awakened them. Dr. Varga's team began to model the temperatures needed to preserve those compounds. They found that, improbably, the energy of the impact would have heated the material just enough to liquefy ices, briefly, creating a kind of transient chemistry lab in motion, then cooled rapidly before destruction could occur. "Too neat to be chance," she said. "Too precise to be chaos." One technician compared it to a defibrillator, a spark, perfectly timed, jolting something dormant back to activity. It was hard not to think about panspermia, the idea that life, or at least its ingredients, travel between stars, hitching rides on comets and asteroids. But this felt different. This wasn't nature tossing seeds blindly into the dark. This looked like cultivation. Someone in the control room whispered, "What if it's carrying something, waiting to wake up?" The words hung there, absurd and thrilling. The next day, Webb's instruments detected something even stranger. Trace thermal radiation in the same organic bands, not just reflection, but emission. The molecules weren't just absorbing light, they were glowing on their own. Chemical fluorescence, maybe. Or something metabolizing. The data couldn't confirm it, but the thought lingered. Somewhere between imagination and mathematics, the story had changed again. 3. I Atlas was no longer just a rock or a probe or an accident. It was something that could carry or create the conditions for life. And as Webb stared, patient as ever, the organics kept glowing in their fragile dance of warmth and order too complex to ignore, too delicate to last. In the coldest place imaginable, something was stirring, quietly, softly, beneath a layer of starlight and silence. And for once, even the scientists didn't argue. They just watched, awed, as the faint hum of life's alphabet whispered from across the void. Let's begin, where science starts to sound like poetry, the moment when data stops behaving like data and begins to feel like a mirror. Because somewhere between probability curves and chemical spectra, 3I Atlas had crossed a line. It was no longer just an object moving through the solar system. It was a question that refused to stay quiet. That discovery turned the story from cosmic curiosity to existential puzzle. Because if those molecules were real, then life, or at least its building blocks, didn't just survive interstellar travel. It thrived in it. 2 visitors from other stars had met in our solar system, and from the wreckage, the ingredients of biology were now adrift in the sun's light. The paradox was simple enough to be terrifying. How could life's chemistry exist between stars, in freezing, airless, radiation-soaked darkness, and not just persist, but activate after a collision that should have destroyed it? Webb's data didn't lie. The organic molecules were there, shimmering like embers in the cold. Some were as complex as amino acid precursors. Others formed long carbon chains, the kind that make up membranes, the thin skins between chaos and order. And all of it, every fragile molecule, should have been vaporized in seconds. But it wasn't. The energy from the impact had melted the surrounding ice, just enough to let reactions happen. And when the materials cooled again, they froze into place, locked in mid-motion, as though the collision had pressed pause on creation itself. One researcher described it beautifully in her report. It's like watching a sentence being written in the dark, each word freezing before the next appears. The Rhines scried, and when we fact, the more they studied it, the more impossible it became. Organic chemistry requires warmth and stability. Space offers neither. Radiation, vacuum, and time should have shredded those molecules ages ago. Yet here they were, pristine, glimmering, delicate. It wasn't just survival, it was intention. What if life didn't just endure the void? What if it preferred it? Dr. Varga, ever the skeptic, called this the paradox of the warm cold. She scribbled it in her notebook. Life that blooms in the absence of comfort, a biology of austerity. If that was true, it upended everything, because it meant life might not be fragile at all. It might be inevitable, a stubborn chemistry that thrives anywhere, even in the black between suns. Some scientists began calling 3I Atlas the Ark, not because it carried life, but because it carried proof that life didn't need permission, that it could exist beyond planets, beyond atmospheres, floating, sleeping, waiting for the right spark. In quiet labs, they started running analog experiments, blasting organic compounds with radiation while freezing them to near zero. The results were unsettlingly similar to Webb's data. Complex molecules reformed instead of breaking apart. Some even became more stable after exposure. As one chemist put it, "We're discovering that the universe might be the world's oldest biolab." Others went further. They suggested that 3I Atlas wasn't just carrying the ingredients, it might have manufactured them. Its collision, its heat cycles, its inner lattice of metals, all the pieces resembled the workings of a chemical reactor, a slow, deliberate machine for building life's alphabet. The press caught wind of this theory almost instantly. Alien terraformer, one headline read. Another, cosmic bakery, the comet that cooks DNA. Scientists groaned, but secretly, some of them weren't laughing, because when they mapped the chemical distribution, it wasn't random. The heavier organic compounds clustered in the same regions as the alloy signatures, the same mysterious metal that had seemed almost alive. It was as if the organics and the alloy were working together, matter and machine, chemistry and computation. That's when a physicist from Kyoto asked the question that silenced the room. What if the metal isn't just carrying the organics? What if it's teaching them? No one laughed at that either. Think about it, a material that regulates heat, responds to stimuli, and shelters chemistry delicate enough to form life. That's not just protection, that's mentorship, the kind that stars might offer their children. If stars had children, the paradox deepened. If life's molecules were born from collision and chaos, then maybe order wasn't the default of the universe. Maybe life was what happens when chaos learns rhythm. When Webb sent back its final readings, the organics were still glowing faintly, rhythmically in sync with 3 I-Atlas's 6-hour pulse. The same heartbeat that began after the collision now echoed through matter that shouldn't even have consciousness, let alone coordination. Life is a spectrum, one researcher whispered, and maybe we're just at one end of it. For the first time, the scientists stopped arguing. They sat in silence, surrounded by data, each quietly realizing what that might mean. If the organics on 3I Atlas could endure, adapt, and even synchronize with its rhythm, then life wasn't Earth's story. It was the universe's accent. The paradox wasn't that life had survived space. The paradox was that it had needed it. And somewhere beyond Neptune, 3I Atlas kept drifting, pulsing in the dark, carrying its quiet paradox through the solar wind. The chemistry of life, still glowing, still patient, still utterly indifferent to whether anyone believed. Let's turn our eyes sunward now, back toward warmth, light, and the steady hum of gravity that calls everything home eventually. The story of 3I Atlas should have been ending by now, fading gracefully into the outer dark. But space has a habit of rewriting its conclusions. Sometimes, what looks like a farewell is just a pause before the encore. Weeks passed, then months. The fragments of 3I Atlas began to move sunward, caught in a slow, inward spiral. It wasn't dramatic, just a gentle curve, a changing course so subtle that only precision instruments could tell. But that curve was enough. It meant the story wasn't over. It was coming closer. At first, the analysts dismissed it as solar radiation pressure. The sun's photons, after all, are relentless tiny impacts of light pushing on every exposed surface. But those forces are predictable, and this wasn't. The drift wasn't random or evenly distributed. Each fragment curved inward at slightly different rates, all tracing spirals that seemed choreographed. One astronomer compared it to leaves in a stream, not tumbling aimlessly but curling toward the same hidden eddy. The European Space Observatory plotted the vectors, and the curves intersected right at the inner solar system, within the orbit of Mars, a place no interstellar object should willingly wander. Even stranger, the inward drift followed the same rhythmic intervals as before, 6 hours between micro-adjustments, as though something inside the fragments was still awake. They were moving, pulsing, and turning with intention. By now, scientists had stopped using words like anomalous. They'd run out of euphemisms. Quietly, in technical papers buried under cautious titles, they began to use another phrase, directed migration. It sounded almost biological. In Pasadena, a low-orbit trajectory engineer named Ruiz ran long-term projections. When he factored in solar radiation, gravitational resonances, and even the drag of the solar wind, the path converged neatly, not on a random location, but along a stable corridor near the orbit of Venus. That kind of precision didn't happen by chance. When he sent his findings to the task force, his supervisor replied with one sentence, "This changes everything." And it did, because that inward drift, that quiet, patient spiral, defied every expectation of interstellar debris. It was as if 3I, Atlas, and its fragments had switched from escape mode to return mode. But return to what? Telescopes from Chile to Hawaii began tracking it again. The fragments, once scattered, seemed to be reassembling, not merging, exactly more like forming a loose constellation, a formation. Their positions relative to each other stabilized over time, creating patterns of symmetry. When plotted, those points of light formed a rough shape, a ring, faint but deliberate, a ring spiraling inward. The pattern echoed something the Geneva simulations had shown months earlier, the circular symmetry left behind after the impact. Now, that pattern was playing out on a scale millions of kilometers wide. Dr. Varga, watching the new data feed late one night, said softly, "It's not drifting, it's remembering." Her assistant didn't understand. Remembering what? She didn't answer. The press never heard about that quote. Of course, the agencies agreed to keep the movement classified as inconclusive. But word leaks faster than light in the age of the internet. Amateur astronomers began comparing long exposure photos, stacking frames, tracing subtle arcs in the stars. And sure enough, the curves were real. The fragments of 3I Atlas were spiraling inward, slow and deliberate, like something tracing its way back to a beacon buried deep within the solar system. When the James Webb telescope recalibrated for one last look, it detected a faint increase in the infrared pulses. The rhythm hadn't changed, but the intensity had. Each pulse grew slightly warmer, as though proximity to sunlight was recharging whatever slept within. You could almost call it migration, or awakening, or return. And somewhere in that slow drift, humanity began to feel something primal, the mix of wonder and unease that comes when the unknown stops being distant. When it starts heading your way, in a public statement, NASA called it a natural orbital evolution consistent with solar influence. The phrasing was clinical, perfectly boring. But within private notes, the language grew stranger. Coordinated acceleration, persistent alignment, thermal feedback, consistency, translated into human terms. It knows where it's going. There's something unnerving about an object that doesn't stop. It isn't chasing or fleeing. It's following. It has no hurry, no hesitation, no fear. And still it moves inward. Weeks stretch into months. The fragments shimmer faintly in reflected light, too dim for the naked eye, too disciplined to call coincidence. Somewhere beyond Mars, they turn as one. The data comes in soft pings across the deep space network, small fluctuations, timed perfectly, a rhythm, a breath. By now, the scientists no longer talk about it as a singular object. They call it a system, an organism perhaps, a machine maybe. But the question no one says aloud, not in the briefings, not in the journals, is the one that lingers over every new plot line. If it's coming inward, what happens when it arrives? You picture it now, 5 faint glimmers tracing spirals in the dark, inching sunward, gliding through the gravitational web, like dancers who already know the steps, not rushing, not attacking, just moving, perfectly timed, toward the light. And maybe that's what the story was always leading to. Not a crash, not a discovery, but a return. Something from beyond the stars, coming home by choice. Let's leave the observatories for a moment and look instead through smaller eyes, the ones behind backyard telescopes, beneath cold rooftops, where curiosity isn't funded by governments, but powered by insomnia and instant coffee. For all the billion-dollar optics orbiting Earth, sometimes the universe chooses to reveal its secrets to someone sitting in a lawn chair, wrapped in a blanket, whispering, "Just one more exposure." Somewhere in Chile, a backyard telescope caught something NASA missed: one fragment, larger than the rest, reflecting light in short, precise flashes. Not natural twinkling, but coded rhythm. The observer uploaded the data online. Within hours, the internet was convinced it was Morse code. Within days, scientists confirmed it wasn't random. The amateur's name was Luis Vega, a retired electrical engineer who'd built his telescope from parts scavenged from an old satellite dish and an antique lens. He didn't believe in aliens. He believed in patience. His nights were spent chasing exoplanet transits and photographing nebulae no one else cared about. But on that night, as he stacked his frames and ran a light curve analysis, he noticed the impossible, the same pulse, repeating 6 hours apart. He thought it was a glitch. Then it happened again. The pattern wasn't noise. It had cadence, structure, 5 short bursts, 1 long, pause, then the same sequence again. Not perfect Morse, but close enough to make the world notice. By morning, Vega's post on an astronomy forum had gone viral. Comments flooded in, amateurs verifying his data, skeptics debunking it, artists turning the pulses into music. Within 12 hours, someone uploaded a track titled "The Atlas Beat Remix." It hit 1 million plays by the next day. NASA's official channels tried to quiet the frenzy, issuing statements about instrumental artifacts. But then the European Space Observatory cross-checked Vega's timestamps. Their own infrared data matched down to the millisecond. The flashes were real. The problem was, they weren't supposed to exist. The fragments of 3I Atlas were too far, too faint, too inert to reflect light in that kind of rhythm. And yet, there it was, a pattern precise enough to defy chance. When scientists mapped the flashes over several rotations, they noticed something even stranger. The pattern wasn't static. It evolved. Each cycle shifted slightly, the intervals stretching and contracting, almost like a modulation. The rhythm was talking to itself. Dr. Alina Varga, now the reluctant face of calm amidst chaos, reviewed the data in disbelief. "It's not a message," she said softly in an interview. "It's a calibration." But to the public, nuance was irrelevant. Calibration sounded like communication. Within days, news outlets broadcast headlines like, "Alien beacon sends code to Earth," "Satellite dishes turn skyward," hashtag campaigns started trending, "Number Atlas signal" became a movement. Meanwhile, the amateur astronomy community split down the middle. Half believed Vega had captured proof of intelligence. The other half accused him of fabricating data to gain fame. He didn't defend himself. He didn't need to. Every night, the flashes kept coming, and anyone with the right equipment could see them too. Even the skeptics fell silent when observatories in Australia, Spain, and Hawaii confirmed synchronization. Across 3 hemispheres, the same rhythmic bursts appeared identical, aligned, unwavering, and then came the detail that no one could explain. The interval between sequences matched the thermal cycles observed months before, the same 6-hour heartbeat. It was as if 3I Atlas and its fragments were still speaking the same language, one made of heat, light, and silence. Some theorized it was an automated beacon, an ancient machine keeping its systems alive. Others imagined it was biological, a kind of electrochemical pulse. But a small, unnerving faction began whispering something else entirely, that it wasn't sending, it was listening. Vega's telescope caught a final anomaly before the weather turned a faint reflected pulse, returning to the fragment, a whisper of light, bouncing back from somewhere else in space. The delay was too precise to be coincidence. It wasn't echo, it was response. He posted his findings. Simple as ever. It's talking to something, not us. The world held its breath. Governments scrambled to access Vega's raw data. Military satellites turned covertly toward the coordinates. For once, the internet and the institutions agreed. Something was happening, and it was happening right above us. In an age of digital noise, where every mystery lasts 5 minutes before explanation smothers it, 3i Atlas had managed to do the unthinkable. It brought back wonder. Children stayed up late, watching amateur live streams, tracing the pattern of the pulses with flashlights against their bedroom walls. Poets wrote about the heartbeat between the stars. Musicians sampled the rhythm into lullabies. And Luis Vega? He went quiet. His last post simply read, "Sometimes the universe says hello. Sometimes it's just checking who's awake." Maybe that's all this was, a cosmic roll call, a flicker in the night, asking nothing more than to be noticed. But if that's true, it means we answered. Let's move closer now, not to the object itself, but to the rhythm it left behind. Because in the end, all mysteries reduce to patterns, and all patterns ask the same question: are you paying attention? The fragments of 3i Atlas had been pulsing for months quietly, steadily, with that same 6-hour beat. But then, the timing changed, just slightly, just enough to make Earth blink back. When researchers finally decoded the pulse spacing, they realized something chilling. The interval matched Earth's rotation. 1 flash per 86,400 seconds, once per day, like a cosmic mirror blinking back at us in time with our own spin. Maybe coincidence, maybe not. At first, no one wanted to believe it. Correlation is cheap, causation is a luxury. But when the data from observatories in Hawaii, Chile, and South Africa aligned, the numbers refused to be ignored. The pulse spacing wasn't drifting randomly. It was locked, synced to the precise period of Earth's rotation, down to the millisecond. It was as though the fragments had chosen a rhythm we'd recognize, a language built not from words, but from time. In one late-night meeting, a young astrophysicist named Hana Ocampo whispered what everyone else was too nervous to say. "It's not sending a message, it's keeping pace." Her mentor frowned. With what? She stared at the screen, the faint spikes of light repeating like a heartbeat. With us. The silence that followed wasn't academic. It was the kind of silence that comes when the math feels personal. They tried to debunk it, of course. Maybe the alignment was an illusion, an artifact of observation windows or Earth-based calibration errors. But when satellites orbiting outside the planet's shadow confirmed the same pattern, the excuses crumbled. The pulse wasn't earthbound. It was real. And then came the second discovery. The flashes weren't just once every Earth day. They were offset slightly, ahead by 2 milliseconds each cycle. Subtle, but measurable. The pulse was drifting forward, anticipating Earth's rotation, as if predicting the next spin before it happened. Someone joked, "It's keeping time better than our atomic clocks." No one laughed. The implications were absurd and terrifying. For the pulse to align that precisely, 3i Atlas would need to know Earth's rotation rate, observe it, and then modulate its own emissions accordingly. all across astronomical distances. That required observation, adaptation, and intent. The scientists tried to stay rational. It could be coincidence, they said. But coincidence rarely looks this deliberate. In Geneva, Dr. Alina Varga stared at the synchronized pulse graphs projected across the wall. "If this is coincidence," she said, "it's the most poetic one in history. Because it wasn't just matching Earth's day, it was matching its heartbeat. When plotted against human circadian data, the pulse resonated at frequencies eerily close to biological rhythms, the rise and fall of our wake cycles, even the average pattern of human brainwave fluctuations during sleep. It was as if the signal didn't just know the planet's spin, it knew the creatures living on it. The press, as expected, went feral. Alien signals synced with Earth's day, screamed every front page. Theories bloomed like algae in sunlight. Some said it was communication, an invitation. Others claimed it was mimicry, a reflection. A few whispered darker things: surveillance, calibration, or warning. But for the scientists, the real question wasn't what it meant. It was how. No natural process could explain it. Stellar magnetism, solar resonance, orbital harmonics, they all failed. The frequency didn't correspond to any known periodic phenomenon in the solar system. The only body that spun once every 86,400 seconds was Earth. And yet, somehow, something a billion kilometers away was keeping perfect time with us. Some called it the clock handshake. Others called it the echo. When NASA and ESA jointly published their findings, the wording was cautious, almost apologetic. Observed periodicity may indicate mutual synchronization event between terrestrial rotation and external light source. Mechanism unknown, but the private memo leaked later told the real story. Synchronization, not passive. Source adjusted first. In other words, the fragments moved to match us. For a species that had spent millennia wondering if anyone was listening, the idea that something might be mirroring us felt almost worse. It meant it was watching. And yet, the more data came in, the harder it was to fear. The pulses weren't aggressive, not coded, not binary, just light, simple, regular, patient, like breathing. People started calling it the hum. Artists composed symphonies timed to it. Sleep apps used the signal frequency to lull people into rest. Churches began timing evening bells to match its interval, so that heaven and earth might ring together. One priest said, in the noise of the world, a pattern had appeared, not a message, but a rhythm, not communication, but recognition. If 3i Atlas was alive, this was how it said hello, not through words, but through alignment. A shared beat between two spinning bodies across the void. Maybe it was coincidence, maybe it wasn't. But every 86,400 seconds, the sky blinked once, a quiet, cosmic nod, perfectly timed. And for the first time, humanity realized something both humbling and beautiful. The universe doesn't need to shout to get our attention. It just needs to keep time. Let's step into the quiet again, the space after wonder, after panic, after the headlines fade and the world pretends it's moved on. Every discovery has an echo, and eventually, even echoes die out. The sky grows still, the instruments hum to themselves, and the data comes in like slow rain, faint, hesitant, forgettable. That's where we are now. Then, nothing. No more flares, no more signals. The debris drifted quietly, fading into the dark beyond Mars's orbit. The story left the headlines. The public moved on. But in the quiet rooms of observatories, data still trickled in. Every few weeks, a faint blip, a whisper from the cold. It's strange how silence can feel louder after so much noise. For months, humanity had stared at 3I Atlas like it was a mirror pulsing, glowing alive. Then, just as suddenly as it had arrived in our awareness, it stopped speaking. The rhythm that once matched Earth's rotation went flatline. In Chile, Luis Vega, the amateur who'd first caught the flashes, tried to find them again. Night after night, he aligned his telescope, checked his coordinates, refreshed the feed. Nothing. Just static and stars. He stopped posting updates. Maybe it got bored, he joked once on a live stream, smiling thinly. His followers didn't laugh. They wanted the sky to talk again. The scientists missed it too, though they wouldn't admit that out loud. The silence left a kind of withdrawal. You don't realize how much you've adapted to mystery until it's gone. NASA quietly shut down its public tracking feed. The European Space Agency archived the last readings under a new label: Dormant Object, Non-Active Phase. It sounded neat, safe, finished. But in the smaller research labs, no one believed it was over. Because the silence wasn't empty. Every few weeks, one telescope or another picked up a flicker barely above background radiation. Not enough to prove anything, just enough to ruin sleep. Always the same faint pattern. A soft thermal rise, then decay. The same pulse shape as before, only stretched out, slower, like a heartbeat in hibernation. Some called it ghost noise. Others called it afterglow. Dr. Varga called it memory. She argued that 3I Atlas hadn't gone dark. It had gone quietly functional, like a machine conserving energy after completing its task. What task? Her students asked. She didn't answer. In the absence of new data, the world returned to its normal orbit of trivialities. The media pivoted back to politics and celebrity news. The internet found new conspiracies. The comet became a bedtime story again, a fading entry in Wikipedia, half remembered, half believed. But the scientists kept watching. In Arizona, a graduate researcher named Mina kept a private log of the faint infrared pings that appeared at irregular intervals. She plotted them on a chart, months of near flatline data with tiny, almost imperceptible peaks. When she overlaid those peaks with Earth's position in orbit, her stomach tightened. The faint blips lined up with one thing: Earth's perihelion, the point where we're closest to the Sunday. Whatever was out there pulsed only when we were nearest. She didn't publish that. Not right away. Some discoveries are too quiet to survive the noise of public attention. Instead, she wrote a note in her journal. It's waiting for alignment. Far beyond Mars, the fragments of 3I Atlas continued their drift. No light, no rhythm, no sign of intent. Just the geometry of patience. 5 cold shards, following invisible lines of gravity. But if you magnified the data enough, if you filtered out cosmic rays and instrument chatter, you could still see it. The faintest shimmer, a whisper, not gone, just muted. It's possible the energy had dissipated completely. It's possible the silence was just the natural end of a story that had gone on too long. But those faint, periodic blips told another version, that silence, too, can be communication. Sometimes, the absence of a signal is the signal. Vega once said something similar in an interview before disappearing from public life. Maybe it stopped because it got its answer, he said. Maybe it just wanted to see if we'd notice. He looked up, squinting at the sky that had stopped blinking back, and added, "We did, and that's the truth of it." The silence didn't feel like goodbye. It felt like a pause, the kind that comes before something else begins. In the vacuum between planets, 3I Atlas and its fragments drifted on, invisible to most, alive only in the long exposures of machines still stubborn enough to listen. And every so often, through the hiss of cosmic background noise, came a faint pulse, not loud, not regular, just enough to say, "Still here." Let's end where all good cosmic stories do not with an answer, but with a question that refuses to sleep. Because long after the telescopes turned away, after the signals faded and the world stopped pretending to understand, something remained. Not data, not proof, just that hum in the back of the mind, the one that whispers, what if it meant something? In the end, no one could say for sure what hit 3I Atlas or what it awoke. Maybe it was just rock and ice meeting in the void. Maybe it was an accident older than our Sunday. Or maybe, just maybe, it was a greeting two travelers from distant stars, exchanging stories in the only language the universe truly speaks: light, motion, and silence. Scientists tried to move on. They published their final reports with careful phrases like unresolved non-gravitational anomalies and organic compound retention under low radiation conditions. The language of people who want to sound certain, even when they aren't. But certainty was never the point. Dr. Varga kept her own copy of the data, encrypted, off-network. Sometimes, late at night, she'd reopen the last frame from Webb, that faint infrared glow, shimmering where no heat should be. She never said it aloud, but the look on her face told the truth. She didn't think it was over. In Arizona, Mina, the graduate researcher, kept recording those faint blips that everyone else had dismissed as background noise. They came less often now, once every few months, but the pattern never died completely. It was slower, older, like a heartbeat in deep sleep. And Luis Vega, the amateur astronomer in Chile, still went outside sometimes, pointing his old telescope at the same empty patch of sky. He knew he wouldn't see the flashes again, but he looked anyway, out of habit, out of hope. He said it made him feel like he was part of the conversation, even if the other side had gone quiet. People forget that silence isn't emptiness, it's continuation. The last confirmed data point from 3I Atlas showed a small, precise course correction. One final drift, angled slightly downward, deeper into the plane of the solar system, toward nowhere in particular, just moving, the way all questions move forward. And what a strange comfort that was, that something out there might still be wondering, thinking in its own way, humming the song of its collisions and memories. Maybe it was alive, maybe it was never meant to be. But the idea that a piece of the universe could notice another, could respond, was enough to change how humanity looked at the night. The world's interest had burned out quickly, as it always does. The headlines vanished, the think pieces stopped, and the documentaries lost funding. But something subtler had shifted in the human psyche. Enrollment in astronomy courses quietly doubled. Sales of telescopes spiked again. And people, ordinary people, started going outside just to look up more often. It wasn't about aliens anymore. It was about listening. There's a kind of peace in knowing that not everything demands an answer. Some mysteries just want to sit beside you while you fall asleep. Because if 3I Atlas taught us anything, it's that the universe doesn't need to explain itself. It just keeps moving, brushing against itself in endless combinations, collisions that make light, silence that leaves questions. Somewhere beyond Mars, in the soft darkness of space, the merged traveler drifts on, unhurried, unbothered, perhaps unaware that it changed an entire planet's imagination. Maybe it was a machine built for a purpose we'll never guess. Maybe it was a geological coincidence mistaken for poetry. Or maybe it was proof that even across billions of kilometers, the cosmos can still whisper, "I see you." The last entry in Dr. Varga's personal log said it best. The universe doesn't answer, it reflects. Maybe that's enough. And so the story of 3i Atlas ends the only way it could not, with revelation, but with a kind of grace. The object fades into the dark, carrying its unknowns with it. The scientists sleep, the telescopes blink, the Earth spins, keeping time with a rhythm it no longer hears. But every now and then, when the night is still and the stars are sharp, someone somewhere points upward and wonders what if it really did wave back.